we can. Oh, okay.
It's already recording, I think, isn't it? There is a rec here. No? There's a blinking rec.
I think it just started.
Ah, okay. Yeah.
Okay, Javier.
Okay, Javier. Cool.
Thank you.
Okay, Aderson, I don't know if you want to begin.
I could, yes. Hello, everybody. Good morning. Today we have our final day of our summit. And to open this day, I have the great pleasure to introduce you Professor Marcelo Bianchi. Marcelo is a professor at the Institute of Astronomy, Geophysics, and Atmospheric Science from the São Paulo University. He's deeply involved into methods for detecting seismic events in crustal and mantle structures. He also has experience as a researcher at the Schlumberger Research Center in Stavanger in Norway, and also sometime he worked in Potsdam in Germany, and has a vast experience in programming language, and also has been quite responsible for most of the developments of ideas, data management that we see nowadays in the Brazilian seismographic network. So it's a great pleasure to have you, Marcelo. Thank you very much for accepting this invitation for both the talk and the follow-up discussion that we have. I know that this year was quite hectic year. A few weeks ago, Marcelo and me, we were also involved in a symposium that took another 3 or 4 very intensive days of our week. And I thank him so much for having this availability here, and I hope everybody enjoys his conference. And I'll let the floor to you. Thank you, Marcelo, again.
Thank you, Aderson. Thank you, everyone. And thank you for the presentation. I hope we have a nice session now. I will share my screen so that we can start. Let's find the buttons here. Okay, part of it. Okay, good. So let me know if the screen is okay for you.
Yes, it is.
And I can see the chat. So if anyone have questions or want to send message, don't worry and just write me in the chat, and I try to keep the eye on it. So I will talk now about real-time detection and nucleation of small earthquakes in South America. So as Aderson, he presented me, and I just like to also say that this work has a lot of collaboration from Vitor Salles, that is today a master's student working with me. And I took some very recent results of Camilo Munoz, that is another student that passed by the USP, to give an overview of what we are doing a little bit. So before I started, I would like to thank all the team that is making this event possible, especially Genoveva and Aderson for heading this up, and all the researchers that are with us this week, giving talks, discussions, and everything. And it's really a pleasure to participate. Like Aderson said, it was a very intense year, and for me at least, this is my last the last events that I'm trying to succeed here this year, and after that will be more relaxing, just to do normal stuff again. So this presentation, I want to talk to you. I will try to talk about these things here, like basically earthquake location of what I will talk about. I will try to give an overview of concepts to put everyone on same ground. That's the idea here. I will say some things of how we are failing with the Brazilian seismographic network. That's my view. And then I will move to the Guyana event sequence. And it's, for me, this is a work I did that is basically what the Brazilian seismographic network should aim for the future. And finally, I will discuss some ongoing actions, like what we are doing to improve this matter a little bit. So let's go for the first step, talking a little bit about earthquake location. I bring here a map of earthquakes in the world. This is the map from the 30s, basically. This is a map from 1913 to 1930 that was put up together probably by Gutenberg at the time. And of course, this is the first thing that a seismologist did mostly and is still doing today, that is locating earthquakes. And this started a little bit earlier from these two fellows here that I have a lot of interest. That is, the first one is it's Pauschwitz and Ernest Hibel Pauschwitz, that he worked in Germany. More specifically, it worked in Potsdam, where the GFZ is, and the other one is John Mine, that is a great fellow that lived basically England and moved to Japan for some parts of the year of his life, and coming back, he set up one of the first networks of global monitoring. And John Mine used to say that it's not unlikely that every large earthquake might, with proper appliances, be recorded at any point of the globe. And this was pre-1900, basically. It was very early seismologists that pushed it. Actually, Pauschwitz was not really a seismologist. He was working with astronomy. But he made the first instrument capable of recording teleseismic waves overall. And this is the things that seismologists do all the time. And it continued to do, not like a legacy task. So, but before we move, like the big question is, what is an earthquake, or how we can understand earthquakes in this presentation? So for me, earthquake is like a physical perturbation that eventually propagates by the medium being recorded by proper seismic stations at different distances. So basically here, this is a video that I showed to you about the USRA. It's a USRA product that shows a composite image of ground displacements by several earthquakes that happens here in the close to the south part of US, around the Gulf. And its seismic waves, it basically propagates through the array, and we can see that the displacement's moving the ground where it passes on, and we can see the P waves and the S waves at the front, followed by the surface waves, each of them with their own characteristics. And on the other hand, here's a photograph from 891 in Japan, showing a scarp that is left as an earthquake. So basically, earthquakes are like static perturbations at the location of the earthquake, and afterwards it generates like elastic waves that propagates, and waves is this perturbation that is being recorded by instruments somehow. So when we move them, seismology basically uses a lot of seismic stations and records. So this energy that is propagated through the earth, it basically is recorded as a ground displacement at some points. That is, for example, this is a station in Brazil. It's called a CLDB station in Colíder, north of Mato Grosso. And when we think about an earthquake, and this is a pretty a nice record of earthquake that happened some days ago, 2811, of magnitude 7.4 in North Peru, that is recorded by the Brazilian seismographic networks. And each station basically records a 3-component time series that actually is the decomposition of the absolute ground motion at the stations. And some characteristics that we see is like time increases with distance from the epicenter. And also we can see many different phases. If we zoom in, like here, it's the seismogram of that station, the collider stations, recorded by a nanometrics broadband sensors. Broadband in the sense that it can record many different frequencies, like a very broad, like from 120 seconds to almost 50 hertz, where we can see the clear P wave arrival, the S wave arrival, and the other phases. And basically the information that we want, and the information that we as seismologists or data scientists wants to deal with, is basically phase arrival times. That is the most simple information. After that, we can also look to amplitudes, but summing to these two things, we also have the polarization ideas, or how the wave is polarized when it's reaching the instruments at different stations. So all these things is what seismologists had to basically locate the earthquake. So we have all these things from stations, and we need to combine them to do a location. And this is what we have our system in USP doing all the time. So this is the example for the Amargosa events. This is a real-time video for our system. I will speed up a little bit, that it's showing how the Amargosa event was recorded by the network. So you can see here, basically the real-time waves coming mostly of noise, and some station is starting to record a transient signal. And when the transient signal is automatically picked up by the system, the station starts to blink. And the system is basically following those steps here, like detection, nucleation, location, association, and relocation to declare an event. And that's what's the role of basically declaring an event. So if we see the system initially doesn't know what station arrived first or afterwards, or neither which stations are there until it locates the earthquake. When it locates the earthquakes, it can properly sort the data into order that is according to distance. And this reflects the idea that seismic signals, it's a wave, and a wave is a function of space and time that binds both of them, that is the space and time relations. So that's what the system basically used. So stations close to the epicenters record earlier, stations further from the epicenter record afterwards. But note that there is a lot of efforts in the system to nucleate the events, or saying that initially, if I don't know what's the events, I cannot say what station was first or later. So it's pretty hard to get the sense of order. And after that, he has to associate phases, or is just the idea that some stations, for example, those in red here, are not yet associated to the events, or basically they have a phase signal, or a phase or amplitude change was observed by the automatic system, but these marks could not still be incorporated into the solution. And if I keep playing the video, then they would be associated to events and turn green as the others here. And here, after the earthquake has of course, the hypocenter determining and the origin time, it can start the simulation of the waves propagation. So that's basically the steps that the real-time system does. And of course, declaring an earthquake, when we think about this, is the process. Like the process of declaring an earthquake involves all the process of collecting enough information, and that information comes basically from seismic stations. And this information has to be back propagated in time and space until they coincide at a point in space and time. So that's the idea that we call then back propagation. And when we have this idea of back propagation, it's pretty similar to the idea that the earthquake in its most simple declaration is just like a point. So in catalogs, when we search for earthquake parametric information, we'll find initially coordinates, that it's latitude, longitude, and depth, time, and magnitude after all, but all of this comes from this idea of back propagation that is useful. So when we think about the information attached to this process, we have, like seismologists have spent a lot of time trying to really create a data model to that. And in this data model has some very nice ideas. Like, for example, if we take the QuakeML schema or data model, an earthquake or events, it's basically something that we will never know where it is and when it happens. It's more like a God wishes. And then what the men do is detecting origins, or origins are realizations of a try to locate an event. So basically the event is the truth, and origins are the main tentatives to locate it. When we move on, each origin, it's realized by a set of stations. So we use a set of stations, and with those stations we need we have a time series associated where we grab the phase arrivals or information from. And there are two types here that are arrivals and peaks. And note that a peak is any change or any interesting signal in the record, and arrival is an associated peak to one event or to one origin determined. And after all that, I still have the amplitudes measurements that can give me station magnitudes, and finally a magnitude for the origin. So also during the process of nucleating and locating events, my system needs to deal with these ideas, and also I need to keep track of other things like who localized it, when it was localized, uncertainties, which locator, which model, arrival residuals, and also solution residuals. So all these types of information is part of the system that can deal and locate earthquakes today. And this is a very tricky part that is giving an upgrade to a peak. Like arrivals are peaks that are correctly associated to an event, and it receives a phase denomination. So initially, when I'm analyzing a time series, I just go there and say, okay, look, there's something here, and I call this a peak. But I don't know if it's a P wave, S wave, PKP, PCP, or whatever. And also, I don't know what event generated that phase, or maybe it's not an event, it's just noise in the station. And there is a process that needs to kind of give an upgrade from a peak to an arrival. And that's a kind of tricky part of the things. So the peaks are basically the system that are generating peaks. It made detections for us, like the detection or trigger algorithm are routinely used in seismology, and they have been implemented based on a characteristic functions. And this is an article, I think if I remember well, it's Allen 82, that it's described 3 types of characteristic functions that can be derived from my time series. And he gives here 3 examples. That is one characteristics function, it would be the absolute value of the amplitude of the seismogram. Another characteristic functions is the amplitude of the seismogram squared, and the other characteristic functions would be the amplitude of the seismogram squared plus a derivative of the time series. And it's very interesting that each of those characteristic functions can enhance different aspects somehow, or are more sensitive to things. Like basically what we want is to find changes in amplitude and frequency. So when we have here a very slightly changing signal that has 20% increase of this aspect. So this is a 1 hertz, 1 amplitude, and this is like a 1.2 hertz and 1 amplitude, and this is 1.2 amplitude and 1.2 hertz, so 20% more of increase in these parameters. And when we compare the 3 characteristic functions here, we can see the absolute of the amplitude. It shows almost no change here when I change the frequency, but it can enhance a little bit the amplitude change. Like when I go to epsilon squared here, of course, it amplifies any change in amplitude, but also changing frequency, it's barely like unshow here. And when I start looking to the derivatives of the signal, then I can see here some improvements on both like frequency and time change. But one thing is that like these characteristic functions are used in different detectors, but the most traditional detector used today, it's still the absolute value, that it's not really considers too much frequency change. And what they do with that is basically getting these characteristic functions and, for example, determine the short-term average by the long-term of average of those functions. And that's what we call STA-LTA. Normally, the traditional STA-LTA uses the absolute value of the amplitude of the seismograms. And the idea here that the short-time average finds for transient signals, while the long time average tracks the noise, or basically those windows are trying to measure variance in shorter windows and large windows to declare a detection or not. So that's the thing that is basically behind it. And when we apply those to this is an example for a very close event. This is 5 seconds here that I marked. And when I look to this is the roll traces, and that's the signal filter, like between 1.5 and 3.5, and applied an STA-LTA of 0.45 seconds and 45 seconds. And I see here that the P wave and the S wave, it's marked by a huge increase in these characteristic functions that I can see here, an absolute change in counts of 12, 14, 16, until almost 20 here. And by tuning those parameters, I could enhance, for example, the S wave in relation to the P wave, just making the LTA window larger and also the STA window larger. I could enhance the S in contrast to P. And also there's another set of parameters that does the inverse of that. So tuning this parameter is really a critical point in declaring peaks. That is the start point. When we think about earthquakes, there are basically two types of waves that I expected. One is an impulsive wave, that is a signal that it's kind of very large at start, and the other are emergent waves that are slow growing waves. And of course, like detecting these types of signal, it's still possible with STA, LTA, but it has normally a larger delay associated because the characteristic functions takes longer to increase. So see here that this is 10 seconds. And it is basically the half of the slope that I show here to this emergent peak, if all of you agree that this slope here is similar somehow to what we see here, but in reality this would be kind of 2 times less quicker the raise of this characteristic function than the others. And there's also the issue that these characteristic functions, like it show much more like high places and low places along the signal somehow. And this is for a really traditional record of the Brazilian seismographic network, because our network is very large and normally we are dealing with PN waves that are much more emergent than the real PG wave after all. But when I have a lot of peaks, basically what I like this analogy to say I have a bag of like a Santa Claus bag of peaks. I have a bag of peaks. And when I think about a bag, I'm thinking about things without order or grouping. It's just a group of peaks. And the nucleation process is key here. And it's a process to getting this bag of peaks and declaring a series of groups of peaks that can be attributed to different events, basically. And of course, this sorting process is not pretty stable. In the terms, depends how I start. Normally grouping, I can finish in different solutions. So it's kind of complicated. And what triggers me more is that if I go to the literature, there is very little about that. It's not a well documented process. I know only 2 tools that does this pretty regularly, that is SeisComp and Earthworm. But I'm not aware of other tools that can do this in real time. And normally, in many places, it's a task done mainly by people, by analysts. They just get the bag of picks and group them into events, basically. And of course, that's when I'm talking about global monitoring or real-time monitoring. Of course, in special analysis of local networks, there are more easy ways to do this. And while doing this task, basically, I normally consider a grid, a nucleation grid, and a travel time curve or travel time model. That is a way to predict travel times. So the idea of nucleation events, it's something like that. Imagine that I have a station A that records a peak at 12. And the idea that I can back propagate this peak to any point on the Earth using a model. And if a peak is recorded at station A at 12, it means it departs here from this point at 11:57. But it could also be that it have departed from this other point here close to Uruguay at 11:55. Both of these solutions can get me a peak at 12 o'clock in this station here pretty to the north. So in a way, that's the way that the nucleator works. It consists in sending peaks back in time from a station to many different places over the Earth's surface. And then it basically uses this nucleation grid. After all, SeisComp, like today, what's happened is that SeisComp can only do this with first arrival. And what it does, it searches for places where peak at different stations match at the same time. It basically creates a density functions over the Earth of back projected peaks to remove the spatial term of the propagation and just can do a simple searching time. So the main statement here is that a density of at least y points that is within x seconds that can together be located at z kilometers not far away from a grid point and with a total RMS smaller than w seconds nucleates an event. So that's the idea of the nucleation. So let me see here, Javier wrote something. Yeah, exactly. That's the general idea that is doing today on most of the data centers in the world for the real-time monitoring system. What they keep doing all the time is back-propagating peaks. So it runs the STL-TA, collect peaks, back-propagate all the time, and holds a grid of density functions and searching these density functions for agglomerate of peaks that grabs it and generates an event basically on this main statement that I wrote here. So it's pretty simple idea and it has many drawbacks. And after I can nucleate an event that is grabbing a set of peaks from this bag and put them together. And I know that these peaks are locatable, so I declare an event. And then I have the issue that my wave continues to propagate. And normally I do this nucleation in a matter of 3 minutes after the earthquake happens. And I still collecting peaks. So the new peaks that arrives needs to be back associated into the event. And that's another very tricky part. So location, like when I have the events nucleated, I start to be able to get location, and location is pretty much different from nucleation. The idea of location is an inverse procedure to find the optimal position of the event in space and time that minimizes the set of residuals in an MMQ sense. It just follows the Geiger's approach, that it's a Taylor series expansion of the time or any other information residual expression. And it's iteratively finds the position of the earthquake, and in the end, it finds the depth. It's iterative because it's a nonlinear problem that is being linearized by the Taylor's expansion of the residuals. And in the end, like what happens when I have a new peak, I need to test if the peak matches the already existing events to do the association. And for me, it's like this game here that are kids dancing around chairs, and there is one chair less than the number of kids here. So in the end, maybe some kids will be standing and they will be discarded. So association process, it's kind of an iterative process of trying to bind new peaks to events, relocate and see how does this affect the RMS, and then can be putting back and forth. The problem that isn't a very exhaustive process. And for example, I was dealing with a network of data that has around 700 sensors in a 24 kilometer squared area. And the association process running on a i9 computer, it took it something like 1 hour to succeed, to finish, to associate the peaks. And it's kind of unrealistic somehow, but this idea of association peaks into the known events, it's kind of tricky because it doesn't scale. Basically, that's the main issue. It's a scaling issue that if you put too much stations, it fails miserably. So the overview of what I try to explain to us, to put everyone on the same ground, is something like that. We first get waveforms, filter, running trigger algorithms, and measure amplitudes. Afterwards, we refine the peaking or determining times and generate peaks that are associated and nucleated. And then I started with the location and nucleation procedure, like location and relocation procedure that finally takes me to origins. And remember that an origin is basically a realization of an event. So moving now to the Brazilian seismographic network idea, or what we do now. I first need to introduce the network. So that's our networks. It will be shown here by the white triangles when I finish the movie here, but I'm starting showing here from around 2000. And you can see here that the red stars are the earthquakes, and mostly the earthquakes are located close to stations. So if you look here to the Amazon, normally I don't see too many earthquakes happening in this video that I'm showing. I see some earthquakes here deep to the Andes, but not many of them. As the time goes, we install more stations, and then the stars starts to happen everywhere. So basically the detection of earthquakes really depends on stations and people working. And so 2014 or something around that is when the network was more or less completed. And then we really start to see the north of Brazil, and you can see a lot of increase of activity being detected to the north of the country. And today we are using SeisComp3 system, and it's not really well tuned. So most of the stars that you are seeing popping up here is basically found by my analysts and not by my system, as I'm going to show you. So here is an overall of the events detected between 2014 and 2021. So I take the time span that the network it was complete somehow, and I can see here the light yellow are the manual events. So a manual event, it means that the automatic system failed to catch it, and the orange events are the ones that were catch. And when I remove the kind of the plate tectonic events, or I go just for the stable South America events, you can see that this relation here, it deteriorates a lot. So most of the events are still catch basically manually. So when I say manually, I have a technician that every day prints out a day plot of station and search for the earthquakes. So it's pretty rudimentary. But to understand what is happening, or to move on into that, I have here some statistics about interstation distances. So here in the top plot, I get all the stations that are shown here. And Victor Salles actually computed here the distance between stations. So between two pairs of stations, he computed all the distance and make here those plots to us, where we can see that different networks like the blue, the green, the yellow and orange networks, they more or less have an inter-station average close here to like 800 kilometers or something like that. But what's most important to me is the minimum distance, and that's shown here in the bottom plot, that I can see that we have here around, let's say, 200 kilometers between stations. So most of the time, the Brazilian seismic network has an average of 200 kilometers distance between stations, and it tries to be more or less homogeneous, taking into consideration the continental scale of Brazil. And when we compare this to the capacity of detection, so basically here I showed the maximum detection distance by magnitude. And this here, what we did, we get every event that we know, and we plot here actually the maximum distance that this event was detected by a station. And when we look to this, we can compare here the medians of the distance by ranges of magnitude. So basically, an event between magnitude 1.5 and 2, it was like a median detected at 314 kilometers away. That would be, of course, at the limit here of the detectability somehow for our interstation distances. We have to remember that the detection of events cannot be done with one station, but needs more than one station. So taking these into account, we think that maybe the automatic detection could happen until maybe 2 and 2.5, or being optimistic, I would say about that, because then this would give me 3 to 4 stations in average being detected this event somehow. So, and when we look to what we really have, so for every event, I filter them by magnitudes, and I'm counting the number of peaks again. So if I count the number of peaks by magnitudes, I have here like magnitudes, I have here counts, and I have here P peaks and S peaks of manual events. And on the other side here, I have for the automatic system. So first things to note here is that I don't have any S peak that is automatic. Most of the only peaks that my system can do is P peak. or using P arrivals to nucleate events. But what's most important for me is that this area here that I enhance, I see a lot of difference of density of peaks here in this region that it's not here. And this region is, of course, the most important region for us to trigger, that is the magnitude ranges that we target. And we see that many events have a certain number of peaks, between 5 and 10 peaks. For those magnitudes here, that's maybe the automatic system can do. And if the system can do it, it means that it can be nucleated and located automatically. Just the other information I can give to you here is that the size comp as it is from the factory, it cannot nucleate events with less than 6 automatic peaks. And this is not a methodological limitation, it's just something that is hard-coded in it. So to finish this quick analysis of what the network is doing today, I bring the catalog completeness, or the evolution of the catalog completeness that we have along the years. So here I started from 1940 and to 2018. This is a paper I published with some colleagues about the Brazilian seismographic network in 2018. That we kind of analyze what is the density of events. So here I have time, here I have magnitude. This is each of the events of my catalog. And basically my task here, or your task here, is to look at a constant magnitude, the density of plots by time. If you think the density of plots by time, it doesn't change, it means that my catalog is complete for that time period. And that's what these gray curves here shows me. Or basically these gray curves are interpretative models of catalog completude. So basically, until 1960, we believed to know all earthquakes of magnitude 6 and above. And then from 1960, with the global network, we decreased this threshold to 5 and later on to 5 to 4.5. And then here at 1980, there was kind of an initial idea that we were capable of detecting events until 3.5, that is this old dashed model here. But when we look to the RSBR, or the Brazilian Seismographic Network information that was added later, we see that, well, we were not really complete from 1980 to 2014 for a magnitude 4, because we just see that we really had an increase of density of points after the network is installed. So basically a new idea that we have a 4.5 completeness until 2014 when we think about Brazil as a whole. So that's the state we are now. But now I want to show you what we really can do using the right tuned ways of working. So this is an earthquake sequence that happens here in Guyana this year. So this is from January to April 2021 seismicity. So I want to call your attention to this cluster here, that it's basically a set of events. So it was a set of events where the measure was 5.1, located around 80 kilometers away from Boa Vista city, and there is also a seismic station there. And when we zoom in, we can see here that we have around 31 manual events at this region, and from these 31, again, only 4 were automatically nucleated. So when we move on, this is the day plot of that station. And I don't need to say, but there is much more than 31 events per day, and not in 3 months. So we decided to investigate that. And what we did, we took a cross correlation idea. So we get one event, we generate a template waveform that is we get a tiny event, gets the waveform of these events, filter in a certain frequency band to enhance surface waves. And we start to cross correlating these templates to 4 months of data of that station. And we did that after the main shock, or the 5.1 earthquake. So, and when we do this, we start detecting, and of course, to declare an event, in this case, I need to say a threshold. What's my minimum cross correlates to detect an event? And for doing that, it's pretty an empirical value. I decided to use basically a curve that is this blue curve that I say, okay, so that's my total detection count by detection value. And this is the log curve. And what I analyze here, it's how the inclination or the steepness of my curve varies as I lower my detection threshold. And what I understood is that every time I start detecting noise or I'm doing randomly detecting not related to events, I would have an exponential increase in this curve. And using this, I kind of set my thresholds here, marked in this red line. That would be the minimum value of the detection threshold I use. For each of those templates, I basically choose 3 events. And using that, I came to the realizations that we had thousands of events and not only 31 events. So basically here, the red line, it's the main event time. This is time at the x-axis starting November. The main event was on end of January. And we see that we have more than 300 events associated with a day of the main shock. And of course, following Omori's law, this decreased here as shown, the number of events, but the events continues to happen for months and months after the main shock. And by analyzing the number of events by magnitude of only one station, I could determine a complete magnitude of 1.2 here, more or less by this Gutenberg-Richter relation here. And of course, if I filter the catalog to the complete catalog is showing above, but if I go to all my detections, this is shown below here. And I can see that I have a 4 shock sequence here already in December that passed without any notification from my system. And then following this work, we went there and deployed 4 stations in a different scale. So this was the original scale was 80 kilometers, and that here I moved to 21 kilometers with these 4 stations. In the local network, we tried correlation again, but it did not work because the waveform were too different, and we were back to the detection, picker, nucleation, location procedure. And what we get was this. This is a video showing the time for one day, and each mark here on the top plot is a peak of my records. And the closest station to the epicenter is GUI 4 station, that is this here. So at this station here, you can see a lot of events happening all the time, basically. So here you can see the histogram of the detections in this little time scale here, and this moves on. And what I need to do here is to nucleate events. So basically when there are 3 or 4 stations that have similar times, I just nucleated an event. And this is what I did. I could not use SizeComp for that, but I basically used another tool. And if I let this running, this is just one day. It's thousands and thousands of pics. So this is a static image of static frame of that video. And basically what I did, I run a simple nucleation algorithm that takes the maximum expected difference of travel times between stations. And I grouped the pics. And I can see that for some groups, I see patterns like this. That is first GUI 4, the next GUI 3, GUI 2, GUI 1. That would be an event to the north of the array. And some would be like GUI 4, and then GUI 3, GUI 2, and GUI 1, all in sequence. And this is kind of south, and also other patterns like that. And all these time patterns somehow leads to little changes in epicentral positions. And all these events, after finding the times, were relocated using the Geiger's methods. And the final map I will show you. But before showing you the map, I can show you here the Vedat diagram that shows the difference of P arrival times minus origin time, and the difference between S and P time. And this is a line. And you can see here that most of my automatic peaks, it can be really good associated to a line of a VPVS of 1.67. So when I plot the results as a map, it's pretty amazing that we can see here first the events. So here are the stations, GUI 1, GUI 2, GUI 3, GUI 4. That's the main shock was around here. And most interesting, the best locations here show me the azimuth of the faults. But most interesting than that, I can see here the dipping plane of the faults just using automatic locations with the right algorithms and parameters. And of course, what I learned from that is that a correlation method at a regional station track the time evolution and seismicity rates, while the local networks allow to trace the fault orientation at the surface and at depth. So in the end, my catalog had more than 2,000 events from the regional stations. So I would say that it would be maybe more than 20,000 events on the local network. And only the local network for maybe 20 days of the sequence was around 851 events. So that's the reality of the Guyana event sequence that we did. And to finish my presentation, I just want to show some efforts that we have been doing over the last years to improve the whole network. So we basically focus on instrument operation. That's basic. We try to improve real-time data transmission. We have been focused on data creation and archiving. After all, we also need to do data distribution. And more recently, we have 3 students focus on trying to analyze catalog and results. So the first one was Camilo Munoz Lopez, that he defended his master dissertation this year. It was focused in detection. And then we have Victor Salles, that is an ongoing master student that is trying to focus detection, nucleation, and location. And also there was a undergrad student, that is Julia Prado, that tries to work on a different area, that is discrimination, earthquakes, and quarry blasts. That is another issue that we have. But all of them focus on different approaches. Like Munoz Lopez tries to reproduce a peaked databases, calibration available parameters. So basically he tries to find filter, STA, LTA, trigger on off, and post-processing parameters to match the non-peaked database. So he basically used F1 score, that is something related to precision and recall, is your capacity to avoid bad and find good detections. And on the other hand, Salles tried to focus on adapting the same parameters that Camilo, but not by picking by the peaked database, but basically looking to waveforms. And the results are pointing to similar directions, but with different characteristics. So basically, this is what Camilo did. He just measured the number of real peaks by changing high frequency and lower frequency using a grid search schema. So he tried to maximize the true positives while avoiding false positives. And after running his procedure with grid search that cannot handle all parameters together, he managed to separate. These are histograms of the true positives and false positives, or fake events, where he tries to start with this distribution, that is the histograms overlaps, to a distribution that the real peaks are more close to the manual, that is the reds, than the automatic. And of course, the number of fake detections are lower than the automatic, so I reduce the number of fake detections. And this is one approach. The other approach was the Bayesian inversion that he did at the end, where he tries to optimize all parameters together. Of course, Bayesian was much faster and global search methods that gives better results somehow. But in the end, most of the results he gets comparing the grids, and Bayesian shows little difference. And what Camilo did, he goes station by station. So what's the best parameter per stations? So when we compare, this is a comparison map of the automatic, basically here, yellow is automatic, old automatic, and green is manual events. And if you can see, the automatically barely reproduce the manual. And when he gets his optimized results, here's an example with Bayesian, the automatic are much more closer to the manual. So what's kind of good to what he did But one thing that Camilo never really looked to waveforms during this optimization. And this was kind of unrealistic a little bit, simply because when we apply Camilo results to the continuous records, Salles realized that the amount of peaks generated makes a lot of confusion to the nucleator. And also, what's happened that it doesn't scale. If I put more stations than the 50 stations that Camilo used, this generated a totally unrealistic situation. And basically looking to Camilo parameters, it was kind of out of the intuition. So it was too tight filters. It has small LTA value, so much below intuition. And it was extremely low trigger on values. So that is also much, much below expected. So when we put all this together, it could really reproduce what Camilo asked the system to reproduce. But when we injected real-time waveforms, it kind of lost control. And that's why we decided to look back to waveforms. And this is what Salles did. He tried to improve the parameters by optimizing waveforms. So this example is a filter optimization. So this is the original filter where you can see that the noise is pretty large comparable to waveforms. And after optimizing, I make the noise pretty small in relation to the waveforms. The same thing to my characteristic functions. I try to basically I try to maximize my characteristic functions for the P wave in relation to the noise, but I also don't want to generate secondary S peaks, so I minimize the S in relation to the P. And by also doing this, I try to look to dataset characteristics where I compare magnitude distance to parameters in a cross plot, trying to understand what I'm seeing here. So I have like histograms or high pass filter shows me a clear one model histogram here that I can use this value as a standard. On the other hand, I see some correlation between high pass and distance, between LTA and MAG, that I can use to gain trust in my optimized parameters. And then just to show, this is the results if we get the continuous record and apply to Munoz-Lopes data. We find 257 events. That's 35 are really related to the manual. And when I get the parameters that we are under optimization by the Salles work for the same period, we find 186 events. That is much less than Camilo, but with a better recovery that we have 46 events that coincides with the manual events. And also looking to the distribution here, it sounds a little bit less random for me. And finally, the overall picture that we have right now when we compare many runs like standard, Munoz, and runs 1, 2, 3 of Salles, we can see what I bring this table here is to see the number of peaks we are dealing. So we are here like an unoptimized system generates 1,000 peaks for a certain periods, like Munoz-Lopes parameters, 2,250,000 peaks for 52 stations. And the map that I showed you before, it's a map of this run 2 that had 248 stations with 2.5 million peaks. And if I try to lower the trigger on parameter from 8 to 3, I generated 28 million peaks for 300 station, and I cannot deal this number of peaks. And notice that this trigger on parameter is much below Camilo proposed parameter. So if I lower my trigger on to 1.7 with 300 stations, this data set would grow in a way that I cannot handle it. So we need to work more on that. So my final last remarks is that the large improvements in infrastructure in Brazil was not accompanied by an improvement of procedures. In the continental scale of Brazil and its seismic characteristics, it's pretty difficult to implement a star method. So there is no hole in this box here that I can push all the pieces. It's like I cannot push a star into a square hole. And that's an idea that we have to think for Brazil because it's too much continental. And finally, earthquake location difficulties are increasing with time. And my view that is not because it's a complicated problem, but it's just because people are taking this as granted. Most of the generations of new seismologists learning new advanced methods on how to extract more information from the seismic records, like they stop thinking that the amount of seismological data is increasing and following the trend of the big data. And of course, the ways that I'm doing nucleation, detection, and triggering of events needs to evolve, and we should not take this as granted anymore. So that's what I have to talk to you. I hope I didn't get too long, but you can send me questions at any time. Thank you.
Thank you, Marcelo, for the excellent presentation. Really, it's a kind of a call. Please help us. Yeah.
Exactly. This was the idea. Well, I show you what we can do in Guyana using the right ideas, and I show how miserably we fail in Brazil. That's my view of this, and we need to work.
That's precisely the message, and I thank you for passing through. According to our program, we have, if Genoveva allows me, we have a couple of minutes for a few questions. Is that all right, Genoveva? Because I think many people have many questions.
Yes.
Yeah. Okay.
And they're preparing, I think, for the panel. Otherwise, they will kick you in the panel. I think that there was a question in the chat already.
Okay, let's see that here. I think Javier asked something, but I think Marcelo managed to
I think I answered him during presentation. I think I try at least, but Javier can. I don't know if I was clear enough.
Meanwhile, I have a question. Of course, you have developed a lot of experiments, and well, I mean, you can be happy or not with the results. Something that I mean, that I am attracted about this is that every time, well, they are related either to a master, to a PhD, to a project, etc. What about the maintenance of these experiments? You know, there are more data coming.
They are not experiments, Genoveva. It's a continuous. It's a live.
Yes,
it's live.
but it's experimental. I mean, it's experimental in the sense not of testing, but experiment in the sense that you are using your data, you analyze, you have results, etc. And and who maintains all this? You know, how do you, it's yourself, it's
well, the Brazilian Seismographic Network, it's a couple of institutions. We have 4 institutions. Basically, it's my institution, Aderson institution, University of Brasilia institution, and National Observatory institution. So there are mainly 4 data generators that are the Brazilian Seismographic Brazilian Network institutions or members. Each of them have instruments deployed that receives data in real time. So the data flows openly to anyone.
Yes, but then comes the analytics part.
And then comes the analytic parts. Like we here at University in São Paulo, I have 2 technicians that stay all the time doing nucleation of events. Really, they print out a sheet of paper every day and find earthquakes. And then when they find, they go to the system and analyze. And also they follow the automatic system that it's pretty much unoptimized. But see the issue. I tried to optimize the system some 5 years ago. After a month, the technician came to me and say, "What's happened to the system? It's detecting too much. I cannot handle." And I say, "Okay, I will unoptimize the system." Yeah, exactly.
Okay,
because so I make a tweak, and there is an infrastructure following this project, but it's a live project, and there's many people involved, and the students come and go. most of the time.
Yeah, that was my issue.
Yeah.
That somehow you prepare, they acquire expertise, they know how things work, and then they leave, and so
They go
you
away.
end up with code, with solutions, etc. That might be very important, but if they are not maintained and followed, etc., you might lose this know-how.
Exactly, and you know something it's something clearly for me. You know this STA LTA algorithm that I told you, it was pretty much invested in the 60s. So in the 60s there were a boom of papers about this, and today we use the most dumb one. We use the worst algorithm. We use the absolute norm, and I can show you, and I think I show you that the derivative. When I include the derivative of the signal, I gain a lot. But the SciComp tree that is the most used software, or the most, it's a software that is used everywhere. It doesn't implement this. You know, but I think this is the idea, that the students come, they propose ideas, they test, but we need to push this information back to the real time, to real life.
To real life, yes. It's
this
a
doesn't
matter
happen.
of deployment.
Exactly.
And there, I think that the problem is also that there is a kind of level of human resources that is missing. No, you have well, research and possibilities, etc. But then you need to have this technology transfer, and also people that can be aware of that. And is this Brazil, or is this the world?
I think this is the world aggravated by the fact that we are continental scale.
Okay.
Like Brazil, it's a continental scale country.
Yes.
So if I go to Switzerland, they do much better.
Okay.
But come on,
but
Switzerland. Exactly. Like on the other hand, but then comes the fact, if I go to US, it changed. I think some 10 years ago, we changed it. But what US did, US give to every university a kind of a permission to nationally report their seismicity. So now USGS basically collects information from individual universities and bind the catalog. So maybe they have a complete magnitude of magnitude 2. They can detect any earthquake in US with magnitude 2 or above, but they are working distributed. And this started maybe 10 years, Aderson. Do you remember when USGS starting binding all together?
Right, because they maintain a kind of backbone network, which is somewhat equivalent to our Brazilian seismograph network. And of course, the institutions have their own experiments that they run, their own. Sometimes I'm monitoring a certain specific kind of seismicity for some purpose, for some project. And that goes, in US, that also goes into the melting pot of data.
Yeah,
put it that way.
But then we have a serious issue here that what we do in Brazil, we share waveform data. And sharing waveform, it's much different than sharing parametric data. Because parametric data, it's all those variables here. I need to track IDs of peaks, IDs of arrival, IDs of events, IDs of magnitude stations, who did it, why did it, how did it, everything. So sharing time series, it's easy. If you think about the problem of sharing parametric data, and in seismology, we have a very complicated parametric modeling of data. It's a real complicated relation between those objects that I'm saying here. Like each of those names are kind of objects, data objects that has aggregated metadata in it.
Yes, but if you share this level of granularity, if people are analyzing it, you can expect more accurate results than if you already aggregate and share aggregated data.
Exactly, but I have to see that two peaks from different universities, maybe they happen at the same time series by different processing system with different ideas, but they are in reality the same.
The same, yes.
Yes.
You know, there's a similar problem. I used to work in astronomy, and in astronomy, in fact, the question is whether from one telescope or another you are observing the same entity or not, because
Exactly.
the telescope sees either several, and this is referring to one, and then the other sees just one. And the question is their
association.
Yes, yes.
Yeah.
And the other issue that I think it's really open, I don't know, it's my ignorance or not, but for me, the problem of getting a bag of unsorted things and sorting to groups, it's a problem that depends on how I start the process. So there are some algorithms that are stable and some that are not. And I realize that sometimes I cannot even reproduce my real-time system. Why? Because my real time, I have delays that are randomly because of transmission issues. And then the peaks arrival in a certain order that is not chronological order. And then grouping the peaks into nucleated events behaves one way on the real-time system. And when I try to debug the process of nucleation, I don't know the order that the peaks were generated in the system to inject into my algorithm. And I cannot reproduce the failure because on my test, it nucleates, but the real system didn't nucleate.
And the system is the system keeps changing with time, because it's not the same system that you inject. It's a it's not a truly timing variant system, because if you run, it's not fully timing variant.
But then for me, this means that we need better nucleation algorithms, because this back projection idea needs to be improved somehow with, and I think machine learning can help here.
Yes, I mean, there's a data engineering and data preparation before, just only to understand these kind of things that that you know, but that are not associated to the data. I mean, if I get your time series, I will never know that they come in which conditions they have been produced, and this is the knowledge of the domain.
Yeah,
I think there are other questions.
I think we have another question from Goulart. He asked to speak about relationship between the earthquake and the Brazilian lineament, because Julian showed a relationship in the FAPESP bulletin number 236. Anything?
Do you want to? Well, I can start. Maybe Aderson can. He has much more experience than me, but of course, seismicity to a certain degrees, it's kind of associated. It can be associated to kind of faults or lineaments, but then I think there is kind of a definition what would be the real relation. Sometimes we see pretty much relation of mapped geological structure to seismicity. Sometimes we don't. But the fact that I see today is that if you go to geological maps, there are many different granularities of lineaments, and you can find one that matches. But when you look to the results that I show here, that is this Guyana earthquake system, the thing that the earthquakes are aligned along a line is not the lineament. Basically, what I show there is the rupture area that happens over a fault or a pre-existing weakness zone. And this was kind of a linear. Somehow that's what we expected for the movements. The earthquake is a movement of fractures, and this movement follows kind of a linear patch of earth that moved. But it's this a little bit. So there is, well, people say some relations to lineaments. Some places this is very clear, but some places there is no clear indication about earthquakes on lineaments. That's my view. I don't know.
Yeah, I fully agree. I think we have a normal tendency to, in our brain, to automatically associate the distribution to a set of lineaments that are mapped in a particular way, using a particular criteria. And sometimes this does not reflect the underground reality, because most of the mapping is made out of surface or remote sensing observations. And it's sometimes it's an imprint. What you see nowadays is an imprint of something that already happened. In the case of Brazil, hundreds of millions ago, and it's not one-to-one connected to the nowadays stress field that you're looking. In a few cases, it's possible to correlate, but in most of the cases, like places in stable continental areas, like in Brazil, it's very complicated. It's an issue worldwide. Brazil, China, Canada, contiguous US, South Africa, Australia. It's a big issue because you have all those mapped faults, and then you say, oh, that's the culprit for the earthquake. And when you start to look at the details, it has nothing to do with the earth, with the event. And that's a problem, because if you want to do some kind of hazard assessment using geological information, you have to be careful on what to feed into the model, because what you see not necessarily is going to be something that's moving, or is going to move in a certain time that you want to investigate for any hazard analysis. So it's a big question mark, this. But I agree with you, there is not one-to-one direction.
Yeah. And intraplate earthquakes cannot be understood by looking to tectonic events. Like it's very easy to say where the plate border is and see, oh, there are earthquakes at plate borders. I think Johann did that in 1908, but they already realized the relation of earthquakes to plate borders, even that they didn't know that the plate border were there. But when we look to intraplate case, it's very hard to say what's an earthquake, or how the earthquake happens, or what triggered that earthquake. This intraplate seismicity, it's still open question in seismology. And if we look to the 60s, most of the seismologists believe that we're gonna solve the issue, but we are on 2020, and no, and I really don't think for the next 50 years there will be much progress on that. I think we are doing some progress, but it's still a really hard thing to understand intraplate.
Okay,
Paulo has arrived.
Oh, Paulo has arrived. Bonjour, Paulo. Bon dia. Good morning.
He's just arriving. Let him land. Suddenly, someone. Are you watching me or what?
Do you want to stop for 2 minutes? Maybe, I don't know.
Yes, we can stop. I mean, we can give even 5 minutes at least, that people can. Hi, Paulo. That people can grab a coffee and or something else, so that we can start the panel smoothly. And that I'm going to share the teasing questions for the audience, so that they can have a look and have an idea of the topics that we are going to try to address. Our other panelist, Ramón, Ríos, Viqueira, is also here. So now the audience, you have the link to the teasing questions. The idea with the panel is to have a discussion, a multidisciplinary discussion on the problems that have been presented during the week. And then today, I think that we have we dived into into many problems. I hope that now both communities are more or less acquainted of the vocabulary and the type of problems and the type of data that are around. And so, yes, in 5 minutes, we will come back and we will start the panel.
Thank you. See you soon.
Very good.
See you. I'm going to ask the panelists to open their cameras so that we can have a look at their faces. And I'm going to open my word so that, let me introduce Jose Ramón to Marcelo and Aderson. He knows me already. Hi, Ramón, welcome.
Hi.
And we're just letting Paulo open his camera. I'm going to, for those that connected during coffee break, I'm going to share the, oh, doesn't want to, the TSC questions link. If you are curious about the topics. Paulo, are you there? Do you have problems? Is Zoom making your life miserable? So I'm going to start smoothly. Now we are in a panel session, which means that you can have your coffees, your teas, water or whatever, and you can be prepared to have a nice discussion with our colleagues. So the general title of the panel is Data Science-Based Geophysics, Connections, Challenges, and Research Opportunities. Of course, during the week, we have seen that the main exercise that we have been performing, either through lectures, through keynotes, through discussions, through challenges, has been to get acquainted to those problems in geophysics that where data is a kind of key element in the problem, and how can we, as with our different expertises, can contribute in order to make, to improve the current solutions. But we are also particularly interested in thinking about maybe open research problems that to which we can get closer if we have you integrate, well, physicists integrate data expertise in their teams. So this is the general idea that we had in mind when we as the committee of ADAGEO Summit and School prepared the panel. So I'm going to first introduce the panelists, and then the way we will work will be as follows. Each of the panelists will have minutes to give a statement inspired in the teaching questions and on their expertise and on their ideas about the issues. And then we will open the floor to ask questions among panelists, but particularly with the audience. So the audience, please feel free to ask questions of any kind, not personal questions, but other questions are allowed, so that we can have a nice discussion. So I'm going to first introduce, I'm going to do it very briefly so that we have time to discuss, okay? So Paulo Johann, he has been consultant and active participant in Petróleo Brasileiro in Brazil. He's doctor in engineering, and he has 40 years of experience, more or less, in disciplines like geology, environmental engineering, chemical engineering, petroleum engineering, and he has particularly contributed in reservoir engineering, reservoir geology, monitoring, geophysics, and seismics. This is, of course, a very short overview. Paulo will have time to develop more on his experience. We have José Ramón Ríos Viqueira, who is associate professor at the Department of Electronics, Computer Science of the USC. He is a founding member of the COGRED, which is the Computer Graphics and Engineering Research Group of the USC, and he's member of the research staff of, I'm sorry, my pronunciation, Centro Singular de Investigación y Tecnologías Inteligentes, CITUS. His current research lines are related to the management of very large specific data sets, so in the topic, with special emphasis on spatiotemporal and sensor data. He has participated and led competitive research projects of regional, national, and international scope, and he participated and led technology transfer activities with both companies and public administration, including the creation of a spin-off that is active since 2003. We have Marcelo Bianchi, who is currently a professor at the Instituto de Astronomía, Geofísica, and Ciencias Atmosféricas of Universidad de São Paulo, where he develops research in the area of seismology, basically with the development of methods and procedures for detecting seismic events and studies of crust and mantle structure. He was also, during the years of 2009 to 2010, a research scientist working for Schlumberger's Stavanger Research Center in Norway, and later a researcher inside Geophysics group of Potsdam, Germany. We have Aderson Nascimento, who is a professor in the Department of Geophysics at Federal University of Rio Grande do Norte in Brazil. He holds a BSc in physics and a Master of Science in Geophysics from the UFRN and a PhD in Geophysics of the University of Edinburgh. His main research interests are man-associated and natural earthquakes and seismic interferometry. He joined the UFRN and he was also been actively involved in planning the Geophysics department and the Geophysics undergraduate program. He has served terms as Director of Studies for the Physics and Geophysics programs, and later with a deputy role, and he has contributed as the Deputy International Officer of his university from 2011 to 2017. From 2005 to 11, he also was the NE Brazilian Region Secretary for the Brazilian Geophysical Society. Since 2012, he has been the coordinator of his university seismological lab. This is the panelists. These are the panelists, and now, as I said, what we're going to do is I will open the floor to each of them so that they can present their statement, and then we open the floor for discussion. So I'm just going to, I am going to suggest, since today we have a geophysics content in the morning, I'm going to suggest that we start with José Ramón, going to the database, data, and computer science point of view, and then we will move on to the other panelists. So please, José Ramón, the floor is yours.
Thank you, Genoveva, and hi to all of you. Very nice to meet you all. my background is in computer science, and in particular, my research is related to the data engineering part, and I have specialized on geospatial data. Okay, so the relationship comes from that side. We had some experience in projects related to the management of geospatial and also environmental data. Recent projects related mostly with meteorological data, oceanographic data, and also air quality. And in that projects, we had the privilege to collaborate with experts from the different domains of engineering and from the earth sciences. And that is very, very, very nice for us. And from my experience, well, I also coordinated here at the University of Santiago de Compostela. I invite you all to come to Santiago de Compostela, even if you don't like to visit our apostle. We have many other things here, but we also have a nice way to Santiago. Also, for our friends from Brazil, I think it will be a nice trip coming to Santiago. So here I also coordinated a master in geoinformatics. So I also have experience in trying to do some teaching in this combination of computer science with geosciences and having students from different profiles. So from this experience and trying to catch the teaching questions given by Genoveva, in the first part where you talk about dealing and exploiting data, well, there is a statement there that says that the issue is to deliver pertinent, effective, and meaningful information. Okay. Well, how to do this? This is quite the point, and also to deliver it timely, which is okay. This is the complement. The special, in my opinion, the special issue about the spatial data that is not present in other types of data is the complexity that brings the spatial dimension. Okay, the spatial dimension brings kind of complexity. You have the autocorrelation that you have in time, because normally closer events in time are more related than those that are not closer. But in space, you also have this autocorrelation, and this autocorrelation in space, where values that are close in space normally are, the changes in space are not fast. I mean, they are also correlated. This brings opportunities to do special things with spatial data that are not possible with other types of data, and brings additional complexity and specific structures and specific techniques, etc. So we have a lot of technologies that already deal with the spatial data, but since those technologies are proposed, and I'm speaking about those that are of more general purpose, are proposed by people from the database area, they always think, or they tend to think of space as populated by objects, okay? And as this vision of space as populated by objects, and the tent is to consider mainly the vector representation of geometric objects and integrate this in conventional models like the relational model, etc. So the problem is that that is not the case in the most of the big data that we have. Okay, we have some big data that comes in this form, but most of the data generated by sensors and by models is not working this way. So we have the other kind of data with these properties of space. Okay, this raster data, environmental data that has the spatial dimension and the temporal dimension, and the technologies that we have are not, the technologies that we have in the database area are not well designed for this kind of data. They have the form of very big cubes, very big arrays. Even the data models that we have in data warehousing, the data models, the multidimensional models that we have in data warehouse, they are not prepared to support well sample dimensions. I mean, dimensions that record samples in space and in time, which is what the sensors perform. Okay, they perform sampling. Okay, and this sampling has some characteristics, and we can take advantage of this. So this is one side of the issue, I think, and there are challenges to incorporate and to integrate in databases sampling dimensions in space and in time. And also the other issue is something that I already heard in the previous talk. It is that issue of the semantics. Okay, that issue of I have this temperature from this data set, I have this temperature from this other data set, but when I have to integrate and when I have to deal with those two temperatures, I notice that in the best case, both of them are air temperature. One of them might be water temperature, but even if they are air temperature, one of them might be generated by a meteorological station, maybe by a satellite, maybe by some simulation model, I don't know. And only the experts that know from where to download the data know exactly what they are downloading. The metadata is not always there. And even if some metadata is there, it is not encoded in some standardized way for the tools to understand more or less automatically what they are dealing with. So I think there is another challenge related to the somehow trying to develop more automatic tools to take into account the metadata, okay? The metadata related to all this big data that is already available in meteorology or oceanography, and also in seismology, of course, and in many other disciplines. Nowadays, I have the feeling that only the very experts in each of those topics are ready to take advantage of the data sets that are available. I have this feeling, and that people from that are not from those domains, they have quite a lot of difficulties to get the data they need, okay, and to find it. This is
there is a question on the chat.
Marcelo Bianchi.
Okay.
Yes. Do we need a metadata of metadata to join database from different fields?
Okay, that's a complex question. Yeah, metadata of metadata. Okay, I would be happy if I have just metadata. Okay, metadata of metadata. Of course, that metadata of metadata is what I will call the standards. Okay, what is provenance metadata? What is data quality metadata? If you use some standard, and when they give you a dimension of what they call provenance, if you, or of data quality, if you know what is that about, I mean, what is that metadata is, and also what you expect to have in the data set, because when you query a data set, unless you know the schema, you have a problem, okay? You need to know what you download and what is the meaning of what you download. And this, you have this problem with the data, but you might have also the problem with the metadata if it is not used, it is not aligned with some standard, okay? So of course we need, metadata of metadata to be able to work in a more automatic way, okay? To do more general purpose tools, okay? So this is related to somehow efficient storage and query processing we need to deal with the sampling dimensions, and also we have to deal with this semantic integration, okay, which is an old problem, I will say, but we have specific issues into this domain. And then we have
there is but standards are field related. So you were talking about them, yeah.
A follow-up question, sort of.
Yes, yes, of course. Every field has its own standards. So now you also have the problem of integrating standards from different domains. That's true. And you have some efforts to provide standards. For example, I am aware of the standards of the Open Geospatial Consortium, and also those related. Some of them are also ISO standards, and the effort here in Europe to try to develop this INSPIRE infrastructure, but and the effort, for example, to develop a standard for metadata for environmental observation, which is somehow independent of any field, okay? But of course, what is important in one field might not be so important in some other field, and the terminology in each field is already established, so it is not clear if it will be easy to have a standard for all the fields to be happy with it, or if we have to develop some kind of translators between different standards and to have also integration of metadata, let's say, okay, semantic integration of metadata. But at the end, you need to understand what are the semantics, because otherwise you cannot integrate. That's the issue, okay? And in some cases, when you integrate, you need to lose some specific things, okay, that are specific of a specific domain, and they might be too specific to have in a general purpose tool. But I think that is an old problem in general in data management. The problem of data integration is an old problem. The problem of dealing with semantics in that is also an old problem, and there are many works related to that. And I think they can come into this place, into this topic, and they have specific issues here also. And the specific mainly is in my opinion, the spatial dimension. Okay, what is the spatial dimension of the data? That is also in the metadata, of course. In the metadata, we also have this spatial dimension and the temporal dimension. There is another question related to the secrecy of the and also of the sharing of the data. This is also an old issue. Who is going to pay for the data that I collect? And this is my data I have collected, and how comes that I'm going to share it? Okay, this is an old issue. And how are we going to share the cost of the data generation between all the stakeholders? Okay, should the data be freely available in the web, not freely available, and okay, even if it is not freely available, the data now with the lot of data that the big amount of data that we are generating, even if we want to make it freely available, we don't have to consider only the data generation cost, but it has a data maintenance. Downloading data has a cost. And when a user wants to download the whole data set, maybe it is not feasible. So we still, in some domains, come from a world where the users need to have the data and not rely that the data will be there when they need it. So when they see some open data available, they want to download it because maybe in some months the data is not going to be there. So, and this is a change in our way of doing, okay? But downloading all the data has a cost. Who is going to pay for that cost? For example, in infrastructures like Copernicus, you have to registrate to download data. You ask for the data, and for some data sets that are not directly available, they have to prepare them for you, and then you have a link to download. I mean, there is an infrastructure to download. So it is less accessible. Some kind of data is less accessible because it's not so timely, it's not so recent, and it is not so cheap to make it available. Okay, and this is also an issue to take into account. But there is also another issue related to the secrecy, and also an issue that might bring some controversy, and it is should all the data that I generate be available for everybody in terms of security? I mean, it is secure to provide all the data that I generate to everybody, and of course, in many domains, that is not the case. Think about border surveillance, maritime surveillance, and some applications related to data that are generated that are really, I mean, they are not, they have not been generated for everybody to access them, because there is some risk of having some specific data sets. Okay, so about the secrecy, we have that issue of somehow we don't have here personal data, but we have some data that might be sensible. Okay, and that may be should not be available for everybody. Okay, and this is something that is in the middle between what we need, transparency or other issues that we have to take into account. Okay, about data acquisition, the problem here is always, in my opinion, the issue of having good provenance and quality metadata. That is the key. We need to know what we download. But when we have environmental data, we have environmental data for the same properties. Think about temperature, okay, air temperature. We have air temperature that are generated by models, by sensors, different types of sensors, and the precision of the instruments, the reliability of the data generation process is not the same. And also the temporal and spatial resolution of the data that you generate is not the same. And from those more raw data, you also generate some processed data. So, and you also have those data sets. So it is important for the user to know what is the provenance, what is how the data has been generated, to have an idea of the reliability the user may have in a specific value of temperature at a specific location. Okay, but if that user is not an expert in earth sciences, for normal users, a temperature is a temperature, and when they download data, they expect that that data is correct. So that issue that is true in many application domains. Here, there is not that the data is not correct or not correct. It has been generated in some way. Okay, so that fuzziness has to be, and that different levels of imprecision, fuzziness, etc., have to be incorporated in those metadata. Okay, and that comes to I think the last point that I would like to mention is that when you have a lot of data sets, and you have data sets that comes from physical simulations, okay, in the different domains, you have data sets that come also from experimental models, even from combinations, hybrid models. You have data coming from sensors of many different types. Many times you need to integrate all that data, and the integration has to be done by some kind of data fusion algorithm. Those data fusion algorithms, they should incorporate artificial intelligence or some intelligent technologies, but all this metadata is key to have good data integration, because otherwise you are going to give similar importance to two data sets that really have very different reliability. Okay, so the key issue here is, can we be, I mean, there is some chance to produce some general purpose or generalized approach to do intelligent spatio-temporal data fusion based on those metadata? Can we incorporate in our machine learning techniques those metadata related to the quality or to the precision or to the all that stuff are as first citizens in our techniques? Or are we going to leave them for the expert, and the expert will choose and develop specific data fusion algorithms for each domain and for each specific problem? That is the a question that, okay, that we might raise there. So I think this is more or less what I wanted to say. Maybe it was too long, but I think that is what I will say. Okay.
Thank you, Jose Ramon. As I said, we will move to open the floor later on to a more vivid interaction. Now I'm going to open the floor to Paulo Johann, and well, I let him open his mic. We see his face now. Paulo, you should open your mic. Let me see if I can open it for you.
Okay, it's open
now
right
it's
now.
perfect. Excellent.
You asked me to share right now, Genoveva?
Yes, you can. You have rights to share. I'm not sure because you left and you came back. So just let me. But I think that you have rights to share. Yes.
I tried.
We can see. Yes, we can see your screen. You can choose the presentation mode, but we can see your screen.
Slide.
However, I'm not sure about the voice, but your slides are here.
My question is, if you see first slide with
Yes.
The title.
Yes, with the guy with the.
Yeah, okay, thank you very much.
Yes.
Okay, first of all, thank you to Aderson and this opportunity to share the industry vision related your passion of science of data. It's my passion also. I work my entire life with that, but more applied in Petróleo case. I try to share with you the importance of this area for our business company. Now, this is very, very new. Last week, Thursday, our CEO presented our strategic vision for the next 5 years. And I take the image of in general. This innovation is very important for us. And we invest $1.5 billion in this area in different domains. You see digital twins, robotization, methodology, technology, platform, of course, intelligence, artificial, big data. We have a huge amount of money in this area, HPC, to improve cloud computing. It's a broad vision of our 5 years investment in Brazil in this company. More in detail, a lot of data, it is digital, the proactiveness of technology protection is very important for us. You discussed the subject today, security, how you protect the data, sensitive one and exploratory one is very important for our company. You see here, several different areas and technology very important one, okay? We have a huge research center for innovation in South America and Brazil dedicated for this area. And today, a lot of people here work with the vision of Digital One. We increase our HPC. Right now, Petrobras just launched last year. In the world, the position is very important for us, but also we move for cloud computer. 1 month ago, we call a center of cloud computer in the company to move also to the cloud, okay? Aderson asked me to show a little bit a roadmap of the evolution of this data since the paper, imaging paper, and color pencil used for our job and interpretation. We move along the years with a lot of new technology. Of course, with that is a kind of exponential growth of data, exponential growth of information, exponential growth of needs required to have algorithms, science of data to extract value. And more than that, for us, the key word is to be predictive for the future. We believe science of data is very important to help us to model and to become predictive for the future. And our job is very important to be predictive, okay? Here is very technical one, but it's a systemic vision of different subject we call métier. We work in this business of exploration, production of oil, but HPC, cloud, and you see here, deep learning, machine learning, intelligence artificial is very important for us. And almost everything here is based in algorithm, based in science of data to build our models and to become predictive in our production curves for the future. Only one image, interesting, the recent one.
We are just having a look at the first slide. You are not moving slides if you have done this. We're just having a look to the first one.
First one?
Yes.
Sorry.
I think that you have to move to presentation mode, and then there you can click and then play the presentation mode is to the right at the very bottom of PowerPoint.
Sorry, Genoveva, I didn't understand. I have a last slide here. You could stop here with the big vision of we present. You see it is slide right now or not?
Yes, but we just see the first one, and I think that you are talking. You are using another. Yes, the one with the guy with the
okay.
3D. Mm-hmm.
Which question related with that? I didn't understand.
I'm just saying that we only see that. We do not see that you are moving the slides.
Sorry, sorry for I have some trouble to listen you well in the question.
I'm going to write on the chat so that you can read.
Okay, write for me. The chat. You cannot see the slide moving. I understand. I understand. Sorry about that. Sorry about that. If I move like that, you see the movement, the second one or not? Not.
No.
Okay. Maybe it's in the share here. I could stop to share. I stop to share. I try to share you is there. If I move right now one, you see, Genoveva?
Oh.
Now we see one, the first one, and then click.
The second one, the third one,
Yes,
no?
yes, yes, yes. Yes.
Okay, sorry about that. I could
No
re-explain the second one on screen. You have this kind of arrow of vision, digital transformation, the investment. It's okay. You see 1.6 billion. Okay, thank you. Sorry, apologize for that. But this is our 5 years vision of the investment in this domain of science of data and general aspect of robotization, digital twins in our models, very important technological platform, deep learn, HPC. only my target here to show how the huge commitment of our company relate to this domain. I try to move for the third one. The third one, you see, is a small hexagon, Genoveva. The third slide, move or not? Okay, is there. Here is the vision of the protagonism of different areas in the protection of data, because companies, oil companies have so much data, and today with the very easy to share data and information, the company also need to build strategy, algorithm to protect a little bit the information. Of course, to share and to have partnership over the data with another companies, technological companies, very important for us also. It means not be 100% closed and blocked, but with some security, do the strategy of this data is very important for the company. The third one I would like to show you, it is a visual of our research center, so being important, but Aderson, you see the roadmap of technology. Oh, great. Aderson asked me to say, okay, from the time we use color pencil and the old technology, we use a lot of new exploration, acquisition offshore, onshore in Brazil, and our data grow exponentially, and the information grow exponentially as the reason science of data and the way you could model became predictive with this information is a key element for our industry. Do the huge I point one point for you to give an idea. One survey like that, 2004, the acquisition of data represented terabytes of information, terabyte of data in the input of data. Imagine that with terabyte, the size of database to big data and to work is huge, okay? This is more a picture of different area. We work HPC, deep learn, machine learn, and the old data important for industry. Here's a kind of cartoon one. I don't see you see some light color, blue color. It's the first time we see inside the earth, inside the reservoir, this represent water movement, water saturation. And the dark blue represent the well we inject water with pressure to keep the energy of this reservoir. This is the first time we review the water saturation, 3,000, 4,000 meters of buried inside the earth. For that, you need to manage a lot of data, you know, to generate the Brazilian pre-salt. Those were giant fields. And to close, to summarize, here we build one slide to mention. We invest a lot in HPC. Maybe in the future, quantum computation will come, but right now it's GPU, graphical processing unit, GPU for image. Still keep some CPU also, but GPU is the drive to generate image. We are into this digital revolution with the big companies like Microsoft, Amazon, etc. But also we try to promote here in Brazil startups, small companies, startups and mid-sized startups to become with the big tech companies in the player in our ecosystem of cooperation. And in Brazil, 1 month ago, our government signed the 5G technology. We suppose with 5G technology, we will put a lot of sensors in our offshore project in remote areas, and with Internet of Object, IoT, and 5G technology, the amount of data will increase exponential and twice exponential in the future with the 5G technology came for us. Of course, all deep learn, machine learn, welcome. Cloud computer with us, of course, will be on board of that, okay? In the end, my knowledge to Aderson, Nascimento to give me this opportunity to share for you and to motivate you. And I believe so much science data for in our domain to predict the future for our production curve, for our modeling is a key element because we have a hill of data. We call hill of data. You need to work with this data, with science, to be more predictive. If you became more predictive, you have two things. Not only we make more money, but we became more environmental aligned. Because if you became more predictive, the amount of intervention in the nature, the number of wells you need to drill is less than we use if you not have a smart vision was the best position to drill in the wells. It means we became more effective, less impact of environmental if you are able to predict better. And science of data is a key science for us. Thank you very much for the opportunity.
Thank you very much, Paulo. We keep the questions for the open floor. Now I'm going to open the floor to Marcelo. And please, Marcelo, are you going to share something?
Yeah, it would be good so that I can control.
Okay, so Paulo, can you stop sharing your screen, please, so that Marcelo can show his slides? You just have to click on the green button on the bottom of the Zoom and you stop sharing.
Okay, let me know if it's okay.
Not yet.
Oh, go ahead, please. I miss you. You can see your message. Yes.
Now it's fine. Now it's fine.
Good.
Yes.
Comments
So
on
I
the
just
question. Marcelo Bianchi.
Very
Marcelo.
good. Yeah. Okay. So I follow a little bit the questions from that were there for us a little bit, and basically we need to talk a little bit about dealing and exploiting data, expectations for possible data-centered geophysical practice, and RD. And so I just put here the questions, but I think you can see, but basically it was more to organize myself, and then I move to my points here. So about dealing and exploiting data, my view of the seismological community, we are very organized. Somehow we have formats, we have services that were adopted worldwide, and we also have a positive interaction with companies. Many of the protocols used in instruments that I can buy from a private company uses open source protocols, that is like SeedLink or seed standards, and those are formats that have been developed community-wise in the decade of the 80s, basically. So seismology, I think it's much ahead of any other area of science. When we think about data formats, maybe meteorology comes together a little bit, but seismology, we have been pushing real-time stuff pretty seriously somehow. So I think we are doing good. We face some issues with politicals that when large people are trying to take decisions, it takes more time. But that's okay, because in the end we have something more broad accepted. So just to cite, we have like dataless seed, station XML, QuakeML, FDSN, WS. They are all keywords in seismology today. And just to mention, like when we adopted web services, this was around 2012. It was a revolution in the area that today I can fetch data from seismology pretty easily in a huge amounts. Thinking about seismology is not on the level of the seismic data, but we access a great deal. Nevertheless, seismology opted to go distributed. It's pretty clear that we see in the computer science, Git was a revolution on top of SVN or Mercurial and other distribute or other revision control system. Git proved itself to be the way to go, and seismology also. I remember when I was a grad student, I talked to IRIS chief, it was Tim at the time, and I asked it, come on, Tim, what do I need to be a data center? At that time, there was basically 3 data centers. There was one in US, there is one in Europe, and there was one in Japan that I knew of. And I asked it, I want to be a data center in Brazil. And Tim came to me and said, I don't know. why you are asking me that? And I say, come on, we need to go distribute it. You want data for South America? We should have a data center in South America. But then we are facing synchronization problems. Now we have data spread and distributed that needs to be synchronized, and we don't do it very well. Even in the Brazil, we have 4 data centers in each institutions, and it's non-synchronized. Well, they are kind of synchronized, but not properly merged, or we are missing ways to really fusion the data sets and resynchronize again. So it's good because if somebody destroys data at one place, it's still in another place, but it's bad for the end user that sometimes it fails to get data, but also you are never sure if you get the best data. It's the issue of having more than 2 clocks. What time it is? Well, I don't know. And moving on, we are trying in seismology to avoid micromanagement. This micromanaging is really something that affects our RNH. And we need to decide what to archive, you know? Should I archive raw data? Should I archive synthetic seismograms? I don't know. Like, should I archive cross correlations of raw data? It takes a lot of time to compute, and people are using these as seismograms. And whatever. And this micromanagement is still a lot of discussion in the seismology, like what to archive. I don't know. Maybe a data center should archive everything from synthetic seismograms to cross correlation, or I should archive only data that comes from sensors that cannot be collected again. So these are collected data. But then I see in seismology an issue that is really important. As we discussed it previously, seismology is live. And we are live with very high time precision. We need cents of seconds in the end. And then we have we need precise time. We have continuous records. I cannot stop recording. If I am in the middle of the earthquake, I cannot stop. But even though I need to correct my clock that is drifting, and many companies, they don't really offer a really good solution. Every time I deal with archiving data, I find issues with time. Most of the time, I can even see equipments recording 2 different time series at the same time for the same channel. This is just a matter of filtering and parts of the hardware that needs to be improved. And we need to remember that our instruments are in the middle of nothing. I don't have an atomic clock around. I don't have enough power around. So this is really challenging still on the data side of seismology. When I move to the second part, expectations for a possible data center geophysics, I try to base myself on this table of posed problems from the 60s. And I took 2 of them that I like to bring attention to you. The first one is the less secrecy, more sharing free data. See, I am an institution. I myself am an open people in the sense of I joined the Linux community back in the 90s. So I really believe the philosophy more than the operational system. Of course, from time to time, I balance myself between an MIT license and between a GNU license in terms of say, I can do it for myself, or sometimes I need the collaboration of others. But and I am at the same time a data producer. My institution runs more than 80 stations. And I believe myself that I cannot ask for less secrecy, more sharing, free data. This is something that we need to act. And if users want free data, they should show gratitude to me, because as a data producer, as more gratitude you show to me, this kind of force me or gives me a positive feedback to be more open data. So that's what we did. For example, the Brazilian Seismographic Network, I think one of the reasons it's all open data. And this was something that contaminated. It was my old advisor's wheels, I think Marcelo Assunção, that pushed the other institutions to discuss this. Should we go open data or not? And we see that, I see today that gratitude is something really important on that aspect. We need to be more gratitude from the users. And how to be gratitude? Share your own data. And this will boost me to share my own data. So that's the way it should work somehow, I see, especially on the academic side, not taking too much about this problem of secrecy or all political aspects. And the second thing that's always puzzling me is acceptance of error. When I read this, I have to say I hated it. Basically, before I prefer the question, what is trying to say to me, the error? Like, and I bring two ideas. Complex numbers would never exist if someone accepted that square root of -4 never exists. It's somebody has to question before inventing new things. So errors is trying to say something to you. So don't live with it, question it. And the other thing I would like to call attention, the core of the Earth would still be liquid if Inge Lehmann did not try to explain signals at the shadow zone. So this is something really important. And Gutenberg and Richter, they said that the shadow zone, there would be no P waves, but Inge goes there and proves that there isn't because the nucleus, it's kind of solid. So we should question more, and that's something that calls me attention here. So this is for us to discuss. And the other point is that science based on papers allowed for little to no improvements on how we share. That's, I think it's a big issue in the community, you know, and because basically data and results are not different to me. They are just a matter of perspective. Data producers are not different than other researchers producing results. All produce information in somehow that must be shared and reused to validate progress. You know, and when we get our results and put on a piece of paper that goes to a shelf somewhere, this stops or breaks the thing. So it doesn't matter how much data produce good data. If the results are not re-enter into the cycle by not stopping at the paper published, we cannot evolve somehow. So I think we gain a lot for the data lakes, as Genoveva said, I think, or point me to these words that I didn't knew before. And this is bringing a lot. So I am pushing myself to upload data to data repositories like Zenodo, that's the one I use, but could be Figshare or others. And finally, the last points were R&D perspective, so revolutionary patch breakings. I raised here some points that I think we must pay attention in the seismology. The first is sensors. We have today like distributed acoustic sensing or DAS. That will take us to the ocean. That's my view. Like, I think that when we start using dark fibers that are laying everywhere in the oceans to transform them into seismographs, this could give us a lot of information to do. They are not as good as sensors, but they are worldwide and spread. Also, we are seeing acoustic sensors that could play a role due to cost and simplified operation constraints. You know, like just drop an acoustic sensor in the ocean and start recording, and it's very easy to deploy. But on the other side, we see pretty much developments on rotational seismology and sensors that will add up our constraints to improving modeling. And this comes me to the methodology. When we think about seismology, I still think there is a lot of room for random noise and scatter energy field analysis. Earth doesn't know anything about PNS waves. That's something from our own heads, you know? The thing that Earth propagates perturbation and we think about PNS waves, but there is much more that has been shown to us, like to this noise analysis. But the noise analysis that we do today thinks still a ballistic waves. That are waves that follows a path of propagation, but there are other waves that are not too much touched, that is the scattered waves. And I really think that quantum computers can add to this to analyze fields in seismology or waves that are not so easy to predict, that are more in the Monte Carlo idea of wave propagation than really on the ballistic way of thinking about a wave. And finally, my last thing is an idea of how to do really revolution, you know. First thing, curiosity and intuition versus rational thinking. Rational thinking is boring, slow. Nobody goes nowhere only with rational thinking, because it's too slow to take us somewhere, especially in the big data contexts. So, and then comes curiosity, like these little cats I show here. Can you look to the eyes of this little fellow? And then this brilliant lady on the right side is Inge Lehmann at 13 years old. I can never stop looking to this picture when I need inspiration, because that's the type of questioning eyes that the curiosity and intuition can take us further. And that's where I think we should put our efforts in training intuition that we are losing with time. And also, when we think about machine learning and artificial intelligence, we sell this as a plug and play technology, but it should not be. Like we need it's easy to plug, but should not be easy to play, you know, because people really need to understand that this is not magical, out of control black boxes that can gain, because it made us, I have the feeling that data sciences or machine, not really data science, but machine learning and AI is making us to forget the path that we trailed somehow. So that's the thing. And of course, I think we need to be open in the ends to evolve more quickly than we are when we try to bind things together. So these are a lot of things that I just like to share with you to improve a little bit of discussions, especially focusing on these aspects in the seismological area. So that's the things I had to add. Thank you, Genoveva.
Thank you, Marcelo. I think that Paulo is raising his hand. You can freely open the mic, Paulo, and ask.
I think I wanted to have this time, Marcelo, to say fantastic presentation. Congratulations. I love Marcelo's presentation. Sorry, because I align a lot with my vision, and seismology, of course, is very important for us. And we apply in Petróleo business, but in terms of methodology, equation, and vision, is very much similar. But later on, Marcelo, if you could, I would like to see your opinion to everything you mentioned. I agree is important, but one point maybe we could develop further is the partnership to be faster, to be low expensive in technological development, you know, because in my vision, unfortunately, due to our culture, we are less in the partnership to be faster, to be low cost than we're supposed to do. And you see that in another part of the world. And I bring this question only to provoke me to be Marcelo and myself. We are in Brazil here to see which kind of thing you could improve in this domain, Marcelo. But maybe later on, because we have more presentation, in the end, in the round table, Genoveva, you could keep this question to provoke Marcelo to. Congratulations,
I will provoke
Marcelo.
him.
Fantastic presentation. I appreciate a lot.
He can prepare his shot while Aderson
Thank you.
shares with us.
Yes, I want to start from the end, because the last person to talk is the supposedly, I mean, it's very likely to be many of the subjects are already being exposed and have already been mentioned by other people. But I want to particularly connect two things that are in Paulo's and also in our colleague from Santiago de Compostela regarding innovation. I think as academics in general, we think the model that we have in our mind is that our job finishes when we publish the paper, or when the student has finished a thesis, or when you present something at the conference. The work is sort of already accomplished. Those it's sort of close the book, next one, let's go for the next, yeah? And we basically see that the needs that we have nowadays from the views that we saw from Paulo is regarding innovation and technology, how we do the next step. And that's something I can tell for myself. It's funny because yesterday I had the same conversation or similar conversation with another geophysicist that most people know here, Martin Tigel, that we are discussing exactly about this, because I can tell to myself in the last 2 years, I started to change my view on how we should end our finish. What is my finish line in terms of developing the ideas? And I think it became very clear to me, and yesterday, and listened to Paulo and to Marcelo, that we should also move towards how we can generate companies, how we can generate wealth, how we can generate the circular economy of ideas becoming into products and tackling the challenges that the companies have. And we are, maybe I know the Brazilian reality a bit, and I can tell that it's more complicated than just saying that. And I also want to listen to from other people what's their experience on doing this, especially from our colleague from Spain, how he deals with this, how those things happen. I know maybe it's a long-term process, because at the end of the day, it's dealing with people and dealing with the way we do things. But we have to start at some point, because those are the basic needs that people from the companies, which are the people which are doing the business, people which are extracting oil or extracting any geo resource, at the end of the day, it has to become a product, it has to become something useful for the many challenges that we have as a society, in terms of energy, in terms of geohazard, in terms of climate, etc., etc., etc. So, I mean, my view is that it was very interesting to say that although those things seems at the end of the day very unconnected data and from different people, different perspectives, but I think that we should also, in a way, have never lose this idea that at the end of the day, it has to go to somewhere for someone to use it. And that permeates probably most of the concept that we are talking about: reproducibility, how to share data, how to progress with reproducibility. And this week to me was also in Brazil we say exame de consciência, conscious examination. I didn't have to stay in a dark room brooding, but I had to listen to many of the thoughts and ideas, and many of the preconception that I had regarding data sharing, how to deal with data, are not correct. And that was another bonus from this week, at least to me. And even Javier managed to convince me to use Python now. So it was a big bonus, because, you know, everyone can change at some point of your life, you know. But anyway, I think this idea of how to bring innovation to new products and how to interact with the private sector, with people who are actually doing the business in a daily basis, you know. And I think we have to do this, start changing our minds as academics. As I said at the beginning, we have this idea that our job finished when the student is finished and next one, or our papers published, and we never bother really to document well what we're doing. And it's, if we look for most of the work we do, and if we give the data to someone and do the same thing, following up what I did in my paper, how I describe it, it's going to be a hard time. And sometimes I have the same feeling. I do the same procedures that some papers describe, and there are some things that I say he didn't do it just the way he's describing. There is some catchy thing here. Sometimes you discover by back engineering the the procedures, but it's time consuming, and it's really bad, because it's some of the catchy things are never properly described, and that has to do because we do not have this compromise of saying, okay, someone else is going to use it. We have just the compromise to say the deadline is until the project finished. And therefore, after that, I'm a free man or something like this, you know. And there's something that all this discussion that we have about reproducibility and listening to people from the industry and this perspective, I think it's something that we should always have borne in mind, that at the end of the day, we have to, as much as we can, to share what we do, so that someone can make it and improve it, and also that may become a product that has an interest for the development of a business, or for the development of optimizing a geo resource or whatever, you know. Those are the final words from me, and I'll stop it from now.
Thank you. In order to open the discussion, I'm going to start with the immediate aspect that Aderson put on the table, which is the startup and the story. And I'm going to ask Jose Ramon if you could share about your experience in this startup that you started, and how did you come with the idea, and what have been the lessons that you have learned on this experience?
Yes, sorry, repeat the experience about which one?
Yes, in your CV, you stated that you were at the initiative of a spin-off, no?
Spin-off, yes.
Experience, yes. And so, yes, we would like that you share with us this experience.
Yeah, okay, that is an old one. That was a spin-off that we created when I was working at the University of A Coruña. We were PhD students, and we were developing technologies related in the area of the geographic information systems, but also in the area of digital libraries. And we noticed that there was kind of there was interest in the industry about the works we were doing, and we decided to transfer some of the tools that we were producing in the lab to the industry through this company. The company is still working, and now it is somehow more disconnected than it was from the university, because now the company has its own life, has made independent, let's say, is growing, and that was a very nice experience from us, because okay, it is something like you, as Anderson was telling now, like closing the circle. Okay, the reaching the industry for our work is the end of the path, let's say. Yes, and it's not always that we reach that. So there is some tendency when we write papers to develop very nice solutions to non-existent problems. And to develop very nice solutions to non-existent problems, it is more easy than to develop nice solution for existing problems, because you can always change the problem if you don't reach a good solution. So, but in practice, when you have to deal with issues that are closer to the industry, you cannot change the problem, of course, because it becomes something that is useless. And when you report that your gain in performance is of whatever, it has to have a meaning in real improvement in the industry. I mean, in what does it mean in terms of reduction of costs, or what does it mean in reality, and not just it is 5% faster than the previous one. Okay, so the nice thing about the comments of Anderson, and I think he was putting into discussion a very important issue is what we have to do to close the circle. Okay, we are generating data sets. Okay, but are we thinking in all the potential users of those data sets? Many times we generate the data sets and we think when we share them in our colleagues, okay, in those that are doing similar things than what we do, because those are what they are, who we know. Okay, but for example, here in my university, we had a master student that he needed to do an Android application to do some practice, okay, just to learn, and he decided to use a new data set that was produced by our regional meteorological agency, a meteorological radar, okay, and he developed an application that he called It Rains, okay, It Rains. That was the name of the application, and the application was trying to predict in the next 2 minutes in the place where you are if it is going to rain or not. Okay, this is very short term, like those kind of predictions that they do in the Formula 1 to try to know if it is going to rain in the next curve and they have to change wheels. Okay, this application was downloaded by a lot of people here, and that student did not know anything about meteorological data. He managed to do the application because the data was accessible, and somehow he knew from some I don't know who, where he could find the data. The problem I found is that there is a lot of environmental data in the deep web that is not reachable by users that are not really experts on those data sets. And if that data would be available in a tool like Google, okay, yes, I have the feeling that many more ideas will come to make business out of those data. Business and business models that we cannot even imagine that they could exist. And that is related to publish and make accessible the data to people that you didn't even think that that data would be interesting for them. It is somehow related to many other things that have happened in history. I heard about like the impact that had the alphabet in the improvement of in the construction of empires. Okay, the alphabet make reading and writing much simpler than what it was, and because of that, many more people could do writing and reading, and this make a big change because many people could deal with that. And if we make this somehow more accessible and more available for more people, I have the feeling that we will have more return of this investment that we are doing. Because at the end of the day, when you collect a data set, it takes a lot of time to collect that data set, and what you expect is something to return back from the users also. I agree with Marcelo about the gratitude. but sometimes if it is something more than gratitude, it would also be welcome, I guess. Yes. And many of us are paid from public resources, and to have new business models that produce new taxes, to have more investment in those areas that generated those business models are, I think, in my opinion, this circle that we have to close. Okay. I think that's all. Thank you.
Thank you. Thank you. Marcelo, I will open the floor for you.
Okay.
Yes.
So, well, just I just want to make 2 comments on José talk now, and then I go back to Paulo question, I think. And José, well, listen to you. I came 2 things to me again. The MIT GPL idea, to put everyone on same ground. MIT, it's more a selfish kind of license that, oh, I can handle for myself everything. It doesn't matter how good you are, I'm better than you. That's MIT for me. And when I say GPL license, it's something like, okay, let's do together. I am good, you are good, let's sum and make something great. So, and this goes back to the 80s or 70s for the Unix generation and the hacker communities and everything. But I think it all resides on how educated the population is, or how good we can educate our children, so that they can be in the front of a data set and understand what's the limitations of that. So I see that sometimes the security issue, it has something related like this. For example, in Brazil, here at São Paulo, I don't release automatic earthquakes anymore, because the media normally comes to me and say, what's this earthquake? I say, it's automatic. And they say, well, it doesn't matter, it's in your webpage. So I remove them. I just publish manual earthquakes again, because I get tired of trying to convince people that they need to distinguish things that they doesn't. And then I see that our education is failing somewhere to bring people more aware of things. And of course, it all binds together. Somehow, like, science is evolving very quickly. We are generating a lot of data, but the population itself are not really prepared for all those. And then comes the plug and play issue that I said, that like many things that we have today are plug and play, but they should not be. We need to kind of teaching people, like, it's not because you can plug it plays. You know, it's the idea of generating results for something that you don't even know what it is. And then I don't know if should I go to the Paulo's idea, Genoveva, a little bit?
I mean, yes,
Okay.
yes, because you have to answer, Paulo.
Yeah, exactly. And then Paulo asked me about how to improve this partnership, but then I don't like to answer too much things, and I like to make questions more. So Paulo, like you said sometimes that you are putting 1.6 billion inside developments in Petrobras. But in all these things that Petrobras play, did Petrobras thought about a way to put back to the community than to invest inside the company? You know, like, did you think about tools open to community, and tools that are open in the sense that community can give feedback spontaneously? So like, as an example, I will go back to the computer community or the Linux community. Many of the projects, they invest internally, but they make an open branch in GitHub so that the community can fetch and push back, so spontaneously. So why doesn't Petrobras has an open GitHub of tools that researchers can grab, test, find bugs, and return back without money? Because of course money matters, but money for me, it's a delayed transaction in the sense that you have to pay to get it. You know, the money needs to be involved, but I think what really needs to be thinking about, it's kind of secondary ways of interaction that are more long-term lived and not constrained to project. Projects can be money measured, but some things needs to be a fast track. You know, Petrobras should publish more things openly, like a source codes that you want to test. If you want community to test things, why don't you put GitHub repositories and ask the community, can you look at this? I'm pretty sure people will do if they have the rights to do it. You know, somehow more openly. You don't need to give me the data, but I think data science can now generate a similar data sets based on statistics that is anonymized that you could share with us. You know, you have the real data, you generate a secondary data set from this that is anonymized, but keep the statistics and put to the community to work or help you to write code. You know, and maybe think about this as a way to speed up this thing, or to have like a or make part of the thing more open and long-lived, I think, and not really project-based, because I think sometimes project-based kill stuff. That's something that came to my mind when you ask.
Okay. Genoveva, I could answer a little bit.
Of course. Yeah,
Fantastic. Again, Marcelo, not only your presentation, but right now the way you point the partnership, the openness of companies like Petrobras, I agree 100%. Again, we are very much aligned. But one point, 2 points I would like to mention. Maybe you need to put some reflection.
Yeah.
In my opinion, 2 words very important here. We forget sometimes is cultural behavior.
Yeah.
Cultural behavior in the different countries in the world. You see it right now. Europe push very much renewables energy. But forget we exist 4 billion people in China, India, South Africa would like to get the same standard of life than Europe. This guy need energy, and not only renewable one, but all energy to become little bit my social development. The world is not Europe planet. The world is a world planet. It's not occidental, it's not Europe one only. It means you need to take into account the cultural diversity, cultural behavior in different countries, different companies, in different moments. Norway, for example, is very open to exchange data with the university and open area. England became more open. Companies like Shell have open platform and develop a Studio X. You could develop a kind of open external GitHub for development. Brazil and Petrobras do the monopoly up to 97. Our cultural behavior change, but the cultural dimension changes slowly than technology you could buy or could develop. You need to work in the cultural mind and behavior to improve the openness. Right now, Petrobras moved to startups, to have more startups and small companies, fresh ideas, and to try to open just kind of external development and make more exchange like you mentioned, Marcelo. But in my opinion, it's a question of time. 4 years, 3 years, 10 years, companies like Petrobras with the young generation, young geophysicists, the science data people will open the company for that. It means it's your comment is a kind of trend for the young generation, even internally in the company. But the old guy like myself, you need to improve our mind, our cultural behavior to accept this more openness way to collaborate and the partnership. Great the way you answered me, because it was a little bit this direction I provoke you in terms of how you could collaborate better in South America. Because when you try to analyze, for example, where in the world the hub of technology, today is in Asia or South Korea. South Korea is the hub of innovation technology in the world, China, South Korea. It's not more Europe, not more South America, or never South America, North America. It's Asia. Why in Asia, South Korea countries is a hub of innovation technology in the world? If you see, is the collaboration, partnership, the open mind between these different providers. For a small country like South Korea, this guy is the hub of innovation today. That's the reason I provoke you, Marcelo. Universities like USP, Nordea, another university in Brazil, if you be more South Korea in mind, integrate partnership in South America, maybe South America could be a small or middle-sized hub of innovation technology. But we should collaborate. The behavior to be the best university, or the best place in the Brazilian mind is need to be a kind of individualism decision. Try to be USP the best university in the world. No, Brazilian network of the university should be considered in the world. Not only USP, not only northeast of Brazil. You know, that's my vision. Need to be more collective mind than individual or one or two universities in this country. That's a reason I put some provocation for you, and you reverse to me with some provocation to Petrobras also. Is need to close for that, and you need to improve together. Thank you very much, Marcelo. Fantastic discussion.
We have a question from the audience that goes more or less in the sense of what is being discussed. Well, it's a little bit long, but if I can synthesize, the question is whether instead of trying to be, or in complement of being interactive with across academic and other institutions, couldn't it be more strategic to have collaboration with big companies, for example, Google or similar, in order to use them as first stage in order to go further with the problems that we would like to address? What is your opinion about this?
Well, just quick, I think, again, like all these things that Paulo said and you bring again, they are correlated. And being inside a university, I have a serious issue to do formal collaboration because it takes 3 months for a university to sign anything. And I need to ask my colleagues if I can sign something. And then I can ask the whole institute, the whole university, and then I have to go to a foundation. So I think we need to really need to go more close to these things, or to tackle this in a more timing, to have a fast track way to do this. And for that, we need sometimes to separate. I don't know, I have the feeling that money plays a great delay on that, especially when you go into university and money, it delays everything. And the collaborations is really important for me in a sense that we really need to tackle. And I think the university, it has also the other side, that is education. The university should improve the education. I think the South Korea part, it's a lot about education also, because they have very good education level there. What bursts everything, makes everything easier. And probably maybe in the end is that we have these timing issues, and collaborate with big companies and big universities, it delays stuff a lot. I think like we try to talk to Google to use dark fibers with MIT colleague, and it took 2 months and takes to nothing. First, because environmental regulations of Brazil delayed Google, and then Google itself delayed itself, and then university delayed the other things, and the dark fiber is still dark, and we don't have seismograms. And this is really it kind of frustrates a little bit, and we have this up and down
Marcelo,
I want to do and then go down. So we need to
Marcelo protect us with a word bureaucracy.
Bureaucracy, exactly.
Yeah.
Paulo. Well, it's not a protection. It's a complicator. It's a constraint that's, as big companies plays in the role, situations get complicated because too many interests. And I think I saw a slide during this week about this problem of interdisciplinary discussions, broads a lot and delays again. So then we need to find a balance, and maybe what Paulo said about spin-outs or startups could inject a little bit of energy in the system in terms of acceleration, like acceleration. As one example, SciComp3 system is a spin-out of Geoforschung Zentrum, actually. That was started in 2004. And it's a spin-out, and today it's a company that is called Gempa. But one thing that this company did, it never breaks its relation to the community, and that was great. So the company plugged 3 pieces: the privates, the Geoforschung Zentrum in Germany, and the community, because the community continued to contribute with code fixes and ideas to improve the product that they took out of the institution. So Gempa company brings out the technology from the Geoforschung Zentrum into a private company, but the company, it brings out the technology and the community together. So the community continue to contribute because the company, the spin out, put yourself open to interact with community, and it was great. It worked.
So do you feel that having, I don't know if I had the impression when I visited Jose Ramon that you have in the lab quite an important interaction, at least with community and with industry. Do you feel that having this presence of industrials and government, etc., within a lab is helpful in order to transfer some of the results that are produced inside the lab?
Yes, of course. Having the industry close for us, that, I mean, we work in computer science, so we can play to develop new algorithms, new data structures, new whatever. We can play more with real data or with more synthetic data or with combinations, and also use data sets that are used by the community to generate our papers. But if you have the industry close, then you have more opportunities to develop work that is really interesting for your area. I mean, this is something that is important for us, not only because we have the feeling that we are contributing, but also the image that you produce in the surroundings is positive. We are if we collaborate more with industry and we put our effort in, of course, resolving research problems. We cannot go to resolve applications, okay? But we have to keep on solving research problems, but closer, and also making the effort to make the transfer to the companies. Somehow those companies first have the contact with you and understand better why you are there, and also they can help to convince everybody around that paying taxes for you to do your job, it's important for the country, okay? Otherwise, it seems that you are there playing with your toys, and those toys are not interested for anybody, so why should I pay taxes for that? This is very important, even from the ecosystem. I mean, the political ecosystem, for a politician to convince the people that he's going to invest more in research and development, they also need our help to convince that we are solving problems that are important for the people, okay? And not only that we are playing with our toys, okay? So somehow we have to have this good balance between doing and resolving the problems that we believe are important for the community, but also those that are important for those that pay our salaries, okay? And that combination, I think it is the important. We still are not too close to that in Spain because the way we are evaluated, in the way we are evaluated, the technology transfer is still far from being as important as the papers. Okay, so we still can survive at the university just by doing papers. With those, in some cases, I'm not saying always nice solutions to non-existing problems, but the tendency is to have every time more connection with the industry. And I have the feeling that in the future we will have more and more. And I think that is good. Always keeping in mind that we are the experts in our fields and we also have a word to say. I mean, we also need to have an opinion in what topics we want to research, and we need to research, and not only our companies, okay? Because that will go to the other side, okay? In that side, we also have the experience that if we go to that side, you are going to be, especially if you are at the university here, they can see you as a cheap developer, okay? And that is horrible. I mean, that is the worst thing that we can be. Cheap developers are like moving public funding to the private sector just for free. That we cannot do that, of course. But we have to be connected. That is true. You had the feeling that we are doing that when you were here. I believe that we could do much more than what we do. Because we are not evaluated for that. And that's, in my opinion, that's a problem. If you have a paper, you have 3 papers, 4 papers, you have for sure your complement in the salary. And you have for sure your promotion. If you collaborate with industry, it's not so sure.
Yeah, basically, if you publish papers, you're sorted. If you work with companies, then who is this? What is this guy really trying to do?
You are not real scientist.
Yeah, maybe he's not doing research.
Yeah.
Yes.
Yeah.
Yes.
I have the same feeling as you have.
But I
we
think
are.
we have,
Sorry. No, finish, please.
We have the responsibility to have a good equilibrium there.
So we're reaching to the end of the panel. I would like to make a last round and ask you to say a message, a posture, or a thought that you would like the audience to keep in mind for the next year, that we will certainly have an ADAGEO summit, and that at the end, well, next year we come back and say, oh, I managed to do this, or whatever, or we didn't do anything. It was impossible.
Yes, if I can start, what I will say is that for the people from academia, okay, any company that wants to have a productive business model, at the moment the company starts make a study of the market. Okay, who are our customers and why I need to do this product. So the challenge for us is to work more in this way. When we produce our products, our research results, are they really needed? Who are going to exploit those results? And if I am paid from who I am paid to produce those results. Of course, we have to generate knowledge, and we have to generate engineering solutions for the humanity, okay, let's say. But if we want to make the system practical, we need to think of who is going to pay for that. And everything has a cost, everything.
Thank you. Paulo, what do you say? Or Marcelo, whoever you wants to take the mic. Last message to leave to the
My
audience.
last message is very much aligned with Marcelo. And Marcelo and you try to invite you to promote with your students and research in your university to, in some way, to become more, I say that in English, to building the small company, startup, and to become more entrepreneur, and to try to participate with the companies like Petrobras. We will be each year need to be more open. I agree with Marcelo. We are very big one, very bureaucratic one, very delayed to take this. But we are in the trend to open and to offer for startups the opportunity to collaborate with us. And in science of data, you have a huge opportunity. You have maybe more opportunity than you have professionals in Brazil able to participate to this startup for the future for the company. It means you work in the same area we see in South America and Brazil, huge opportunity, bigger than for geologists, geophysicists, the people who have this background and work in science of data to become more predictive for the future, because we need to optimize the investment through the knowledge, through the best model, the better way to use science of data. And with that, you know very much the subject and should promote the young students, new professional, to participate in small startup, to motivate to become entrepreneur and to approximate with the big company like Petrobras to have opportunity for the future. It still is low, it still is a little bit bureaucratic, it still is not easy, like Marcelo said. 100% I agree with him, but I see the perspective for the next year to improve that, Marcelo. I hope next year will be better than the last 2 years, of course, with COVID, everything you have, but the next year will be better. 2022, I hope will be a great year. And if I could say some words for you, have a good end of this year, Christmas time, and a nice 2022. Thank you very much, Genoveva, Aderson, Marcelo, all to be with us today.
Thank you, Paulo. Marcelo, please.
Yeah, just I really like to participate here in this discussion and all these ideas to be confronted and have the space to talk a little bit and discuss. I agree with José and Paulo. I think that's the way. I think my message is like play more. I think we need to play more. We need to dig more patches and kind of, I think going in the way José said, we need to start asking the questions better. We should not ask for solutions. I think especially for the students, when they look to the things, they have to make questions better, and they not try to focus too much and interact more to improve a little bit the exchange of things, and don't let the things that we already did in the past to die just because of the new things that are coming, but aggregate them somehow. I think that's the way we need to think for maybe for the next year also, to play more and try to not focus us too much in one aspect, but we have to also keep the eye on the broad view. And also this, and this comes all together to the spin out ideas and these new tracks. I think the management or when you think about the private, they have so many good ideas that we at the university should learn from, best practice and everything that could help us, and we need to exercise more and in a way to play more with all these things together. So that's at least for me something for the next year to exercise these ideas more and to take the knowledge I learned today and during this week further and build on top of that. Thank you all the participants, and thank you, Genoveva, for the opportunity.
Thank you, great pleasure. Aderson.
Well, I'll be very brief in terms of, I think, like José mentioned, we are generally what happens at university nowadays, that you have several bosses that that evaluate you at different perspectives. And sometimes you get in this somewhat schizophrenic behavior of who should I write the report for the company? Should I, you know, and sometimes those things are not mutually excluded. It doesn't mean that, and the key to doing this, to succeed, my opinion, it's something that we don't know how to do it very well at university, and people in the company, the impression that I have, they do it a bit better. It's management, how to manage things, how to manage people, how to delegate, sometimes very simple things. And something that I put some effort some years ago to improve those aspects, and it pays back. It's a slow process because we are so intricated with our own little world that sometimes it's hard to make changes. But I think what José mentioned, for example, it's gonna happen in the case of Brazil too, is that people are starting to knock on our doors saying, what are you doing? How important is this to my daily life or whatever? And, you know, at the end of the day, people have the right to ask that, because everything that you do, it's can become a spreadsheet in CSV format. Now I know that, Genoveva. So everything becomes a spreadsheet with a total number at the end of it, and you should, you know, you should comply to that. You should have a look at this, and I mean, it's a very different perspective that company has with dealing with problems. But it's something that we have to learn how to listen to those people, and whatever things we engaged in terms of data science and geoscience, I think this component should never be forgotten, because I think it's a very strong component. At the end of the day, we should have this as this little buzzy thing saying that, look, don't miss. Of course, pay attention to the tree, but look at the forest, because it might tell you a lot of importance to you. And well, we all hope that next year is going to be a bit more, bit different. Oh no, all the years are different, but you know, everyone knows what I mean exactly here. But we should hope for the best and work for the best. So it's been a pleasure here this week, and thank you all the panelists, all the audience, and thank you, Genoveva, for putting up most of those things together here too. And thank you, Paulo, for sharing those thoughts, because they are very insightful from a perspective that our community that we are here, we probably inbreeding would not point out those things that you raised here. So thank you so much again.
Thank you very much. So if I wrap up, we are going to have a lot of fun. We are going to address problems that will be useful for society, and we will not let Paulo get away, because we will contact him in order to try to see how we can define spin-offs together with Petrobras. So, right, Pablo?
Sounds a good plan to me.
Very good. So next year, this will be the objective to address.
Yeah, in the end of the day, the most important thing, the only point maybe I disagree with Marcelo is not make money, but to generate job for the young student professional, because without job, you see in different countries of the world, you have at least 15, 20%, 30% of unemployment. To generate jobs and generate opportunity for the young generation, this is the most important thing, and the most important energy you should be using our life of work. And university in companies, etc. Generate opportunities, jobs for the young generation. This is the most important thing. Because the all automation, all robotization, one of critical point people said for us, maybe you could replace people by machine, people by automatization. And if you did only that, you not generate jobs, not generate opportunity for the next generations. You need to think about to keep going technology, everything related to the high level technology, science data, but not forget you have thousands of people to work, generate job for the people. This is the most important thing, because if the society not have people with the good and not good jobs, you have trouble in the future.
Yeah.
High technology and high level unemployment. It's not a good thing, you know. You need to mix and work together to have job for the people. This is my last statement, Genoveva.
Thank you very much. And this is a great transition because we're going to give 10 minutes break, but then we are going to go to the last part of the event, which is presenting the results that that students prepared to respond to challenges. 10-minute break, and then we have at the end 2 challenging groups. So they will present the results, and we will discuss about them at the last part of the event. So see you in 10 minutes. Thank you very much. Of our event. So for those that are not acquainted of the first part of the event, because you only attended the summit, in fact, the whole event lasted the whole week, and the first days were devoted to a thematic school that has to do with 2 objectives. The first one and the main one was to let people, and particularly students from both communities, geophysics and data science or computing science or statistics, mathematics, to get together and address challenges that the organization committee proposed. A little background about the challenge. The challenges were challenging in many different ways. First of all, because they are related to geophysics problems. So for people coming from non-geophysics domains, well, the challenge, of course, was to understand and get acquainted with the vocabulary, etc., in very short time, because groups worked during 3 days, and so it was a very short time to address the challenges, but it was also a way to understand, for example, and see in practice how difficult it is to acquire the data, understand the data, see that it doesn't come in the formats that we are normally used to receive, etc. And then from the geophysics point of view, it was exactly to ask the questions and see how you can go from the questions to programs that can address at some point the questions that you ask. And so the groups were coached by brave people from both domains that interacted in a very vivid and implicated way with the groups in order to get the experience much more than the results. Okay, so the idea now is that the survivors of the challenges, together with their coaches, I will kindly ask you to open your cameras and your microphones, and then talk about the experience. So it's not really, if you don't have running results, it doesn't matter, but really come back to us with your understanding on the problem and how you manage to design some strategy in order to address the problem. So the first group that is going to come to the scene is Karim Dao. Karim Dao is has just finished his master studies at University Paris Dauphine in Tunisia. And he worked with Plácido Sousa Neto, who is assistant professor at UFRN in Brazil, and with Karen Leopoldino, who is a postdoctoral fellow in the geophysics area, and she was the one who designed the challenge. She perfectly knows the problem. So I will let Karim, and well, Karen, if you don't feel comfortable opening the camera, don't worry, but Karim, if you can please open your camera and then start explaining your experience about this challenge. So I'm going to close my mic and close my camera, so to let you in the stage. Okay, Karim?
Okay. Maybe, hello everyone. Maybe I can start explaining how was the first
Yes.
contact with Karim and Karen, to explain how we divided the challenge in order to Karim try to execute the problem. We have worked in the challenge 3 that was proposed by Karen. The challenge was considering a lithology, a set of rocks, specific rocks, define the sequence considering the depth and also the well with different type of rocks. So the idea was, the input was a set of PDFs, but we started working with only one PDF. Karim, the first activity was understand the input and the problem. So we talk a little bit about the problem. At the beginning, as Karim is from computer science domain, he had some difficulty to understand the idea. So we tried, in the first day, tried to explain the idea. So he got it. And then the first step was to translate the PDF to an image, then extract only the well, and then considering...
I don't know, Karim, can you share your screen and show the kind of files that you receive so that people can have a look at them?
Yes, yes. So at the end, the idea, and the first step was to read the image and extract the well in order to see, at the beginning, we worked to identify the colors of the well and then match with the lithology, considering each step of depth in the well. So he succeeded to identify the colors, but not to match the lithology. So he had only 3 days to work.
Yes, I mean, that was the challenge, is that it was very short time.
So the idea was to, so this is the input, it's a PDF file. So you see the lithology, each one has a different colors. So in order to start processing the image, we asked him to not identify the type of rock, but identify the color of the well. So in each part, identify the color in order to, in the following step, compare with the lithology. So we had the depth here, 5, 10 meters, and so on. So for 5 meters, we have yellow. For 6 meters, we have blue. So 10 meters yellow. So the first output from to Karim was identify the color in the processing of the image. So in the next step, the idea is, I don't know if he succeeded to make the match with the lithology. For each color, identify the rock type, and then have the real output. So the idea was that. So Karim or Karen can talk how was the work. For me, it was interesting too. I had to understand the problem with Karen.
Yeah.
So, and also translate a little bit to French and English was a nice experience.
Okay.
And also pass the activity.
Okay.
So Karim, what we have Karen and Karim. I didn't realize that. Please, Karim.
Okay. Our challenge, we have a data in PDF. We must convert this PDF to image, and the second we are going to extract the deep region for the image from image, and the three steps we must define lithology color and form to we must define predefine the lithology color, and next we are going to parsing the deep we color define and form, and the end we must give put the output and color define on the deep. To do that, we are going to import our library that we must use.
You can share your notebook if you prefer, so you can follow your notebook in the sequence of the steps you use it to solve the problem.
You see my screen or no?
Yes, we see your screen.
Okay.
But we only see the PDF.
Okay.
Yes.
Okay. Data importation and processing. I learned my the PDF file in the Google Drive, and next I make a program to convert this PDF to image file by iteration.
I think that you have to stop sharing and then share again so that we can see your browser if your notebook is on the browser.
Yeah. To open my drive or this is the file for our image convert by a PDF convert.
We are not seeing your browser.
Yeah, but
we are seeing your PDF.
Maybe you can stop sharing and then share again your screen.
Tu peux annuler le partage. Ensuite, tu démarres et tu partages ton desktop. Tu vois ce que je veux dire?
Non.
Oui, en fait, tu dois partager l'ensemble de ton espace de travail de façon à ce qu'on puisse voir ton browser, ton navigateur.
Ah, ok.
Tu vois?
I see.
Voilà, super.
Ok.
Là, on voit tout.
This is it's okay. You
Yes,
see my
perfect.
screen? Okay.
Yes,
Okay.
perfect.
Okay. To test our program, I'm done one PDF file in my drive. Okay. The first file is converted by image, and I displayed that here. We can see that. And next step, I extract the deep region without little lithology legend. And next, I extract the deep region and displace that here. The second step is to detect the different color in the deep. I use the mathematical function to detect that morphology and dilatation and dilatation and that means Gaussian method. But we can see the output to this method using on the image.
So wait a minute. That's the different the extraction of the different colors that you initially have in the PDF. Is this what we're having a look at? Tu vois, les liens qui sont là en couleur, ils représentent quoi? Les morph contours. So that's the.
To detect the color, I use a morphology function to detect the color.
Okay, so you associated the little layers to specific colors.
Yeah.
Yes.
Okay.
Yes.
Okay. Okay.
And the next step, I define color and label color to detect that. I define detect color function and use on the deep image. But the input, the output for that, the first color that I detect is the yellow. That's the truth on my image here. The yellow color, and the next is, but the next I detect a 1, 2, 3, 4, 5, 6, 7, 8, 9 yellow. We have 9 yellow because here we have I don't know the contour of that over here. You might change.
Okay, so it detects 9 layers that are colored in yellow in the initial image. Okay.
Yeah.
Okay.
And next, I detect blue color. And next color detect is the green. And this is we have a problem to detect this color because here I can see we have a problem to the parameter function. I changed that to try to detect color because we have not a well parameter to detect that.
Okay, so the challenge would be, if you want to improve your solution, is to better calibrate the observation of the colors of the layers in order to be able to identify the fine-grained elements of the image.
Yeah. Yes, as you can see, the challenge is to detect the sequence. He detected the number of layers with that colors, but not in sequence.
But not the sequence. Okay.
Not the sequence.
Okay, so it's possible to observe the colors. Okay, so the number of layers is right. Yes. But now the challenge would be to reproduce reproduce it in the same sequence. Okay.
Exactly.
Okay.
So and also compare with the lithology, because for example, yellow represents arenito, blue represents calcarenito. So the idea, the new challenge now is to print the color in sequence, considering the well, and also define this color represents arenito, this color calcarenito, and so on.
Yeah, but that's the correlation with the names. It's just the cherry of the cake. If you manage to get the order, then you name it correctly, and then you have the result. Okay.
Yes, exactly.
Okay. And Karim, what was the most challenging thing of understanding the problem? The concepts of the geophysics domain, or the type of data that you received? What was the most difficult thing to do?
The most difficult is to detect a color on the image, deep image.
Okay, so that was the
problem data, because here we must see we have the mini curve here. But to detect that is very difficult on image detection.
Okay.
You must split
the image.
Each color that in the depth.
Okay.
Yeah.
So you have the feeling that so you did the most difficult part, in your opinion, because now then ordering the layers wouldn't be that difficult if you had more time, for example.
The second problem is here we can see calciurito and calcarant.
They are too close.
Yes, they are too close, so it's another challenge.
Yeah, to make difference.
That's tricky. Yes. To make the difference between both of them, that's a tricky part.
Yeah.
Okay. Something else that you would like to ask about this experience? I mean, you should be very happy, because of course it was 3 days and discovering the problem out of nothing. I mean, we are impressed about the result.
Yeah, really impressive.
Yes. Other comments, Karim, to finish?
Next. Well, the next another problem is to measure the longer of deep here. Color, yeah, here.
Okay.
After detection the color, you must calculate the longer.
The size, the size of the layer.
Yeah.
Okay, so it's about ordering and then about computing the size of the layers.
Yes.
Okay, I see. Very good. Thank you very much to the three of you. And
Thank you. It was a nice
thank you.
experience. I learned a lot.
Very good. Thank you.
Okay.
Thank you. Well done, Karim.
Well done.
Well done, Karim. Really, really nice.
Excellent. So we have other brave challengers that decided to address challenge 1. It was Kera Bakeki with Jaime Converse, and the coaches were Javier and Augusto that we have on the screen. So please, the floor is yours.
Genoveva?
Yes.
I was not in the challenge. I was listening in, but I guess I'm not officially part of the challenge.
But you were a part of the meetings.
Yeah.
Yes. So that's a way of participating.
No. Okay.
No. Don't be afraid.
I mean, you know, even the pizza guy, it's part of the team.
It's an important guy.
Yeah. Here in Brazil, it's called visual support.
You see, we need to be encouraged.
What is it, Martin? Sorry, I couldn't hear.
Visual support, apoio visual.
Okay.
Kiara, I think that we don't get the audio, but we see your image, but we don't get the audio.
Now you can hear me. Now,
yes, now it's perfect. Now it's perfect. Yes.
Yes, but the first problem for me is one of the biggest challenge was to read the data, because the data were binary files that can be read only with a specific library, which is OBS-PI, a Python library. And I had some difficulties in installing it on Google Colab also, because I never used Colab before. So yes, this was a part of the challenge for me, because also Colab has a limited RAM and disk space. And this was difficult, because when you want to do something that requires more disk space or RAM, it crashes and you have to restart from scratch. But whatever, I managed to read the data finally with the help of the coaches. And once I read the data, I put them in a data frame and in a CSV file. So maybe in the future, if someone wants to use them, I'm referring to the data1 folder. These data are in a data frame. Also, since I studied time series anomalies, I noticed that these binary files contains information about the presence of the peak in the sequence, and this is very interesting because it's like having labeled anomalies. Thus, I want to include this information into the data frame. So you will have the time series and an information that indicates where is the peak. But it wasn't so easy because in the documentation of OBS-PI, the T0 either correspond to second peaks. It's not well explained. I tried to find it in other documents, but it wasn't available. The only information they give you is that there is, the meaning is that there are the seconds of the peak. Thus, I tried to add this information to the time of the beginning of the observation. I don't know if this is the right interpretation. Here you can see, so maybe probably someone can understand if it's true or not. Here you can see in orange the position where we have T0 and T1 in this case. Yes, here we have a little peak, but it's not that evident. In my opinion, the main peak is this one. So I don't know if it's okay because this is the first peak, so they detect only this one and this is the information they have. Or I misinterpret the meaning of T0. I don't know. Anyway, now there's a data frame where you have all the values of the time series. Then here I try to consider only 1 hour of the signal, in particular the Z time series, because we have three different time series. One is Z, the other is East, I think, and the other is N, which is North, probably. And so I started the trending the time series because the Z time series was the most difficult because it has a trend normally. So I used the linear regression model to find this line that represents the trend and removed it from the signal, obtaining the trended time series. Then, in this case, I decided to use IQR to find the anomalies. Here you can see that we have some anomalies here in this point where we have the highest peak. And here it's the same signal. It's that the difference is that this is the trended and this is the true signal with the trend, and the anomalies are the same, but here you can understand better why these values are anomalous. And also, if you want less anomalies, you can change this factor. In this case, it's 2, but if you decide to decrease the value, you have more anomalies. So you can decide. Also, I tried another solution. I use the isolation forest to find anomalies. Here you can see that the number of anomalies increase significantly. And for this reason, I had some doubt about the efficiency for this solution. So I decided to try to resample the time series every minute. And I resample it not choosing the mean value as the representative of the interval, but choosing the maximum value. This because the earthquakes or the signal of the S or P signal are composed of 2 parts, one that is negative, we can imagine it negative, and then another one which is a peak. And for this reason, using the mean was not that useful in this case. So here we can see the representation of the resampling with the maximum values, and here we have our peak, which is more clear than before, than here. Okay, this is the peak. Then I use the EQR in this precise case, and in this way we have only this information as an anomaly. And this is important because finally we want to find the earthquake, we want to find it. Then I tried to generalize this solution. Sorry, okay, this is here. In this case, I decided to import the CSV file. So here we are using the CSV file I've created and generated. And we try to use some solution. I've tried to use LSTM. I don't know if you already know what it is, but the problem is that in Colab, it's not possible, it's not feasible with this amount of data. And also it requires a lot of time in general, also doing it locally. So it wasn't feasible in the time I had in this challenge, but probably it's a good solution to use it. Anyway, so since I cannot do it, I have a representation here that describes the values, in this case of the E, okay, and we have all the different values here. It was helpful for me to see at least a part of the time series. Here we have this plot where we can also zoom in or save the image if we want. The problem is that it wasn't feasible to visualize all the time series together, or at least it wasn't possible in my PC because it used your RAM, the RAM of your browser. And here you can see I divided it in sections for this reason, and in this final section is more evident that here probably we have an event and we can zoom and see it more clearly. Then I decided to represent the time series, resampling and visualizing only the maximum values every minute. And in this way, this is the whole signal of the 6 hour that were available in the first folder. And we can see that the position of the earthquake in the time series is more evident, is more clear. Also, I haven't said before, but I have the information of the distance, which was available in the binary file, and I include it in the data frame. But I don't know if it can be helpful. I wasn't able to evaluate the angle or do things like that, also because I hadn't the knowledge to do that and to exactly interpret the values that are described in OVSPI. And for this reason, I've tried to find the earthquakes and the curves and the peak, the S and the P curve as an initially attempt to solve the problem. And here we can see that I resample every 10 seconds the all values because we had a lot of values and it wasn't feasible to represent them in the original. I cannot visualize all together the data if I do not resample. So here I'm resampling with the max values, and that's what I see. These are the last 2 hours, and this is the event. I try to use the rolling mean in this way. We have a factor here that represents the difference between an observation and the mean of a window of a given dimension. In this case is 6, because it's like 1 minute, since the observation are every 10 seconds. And here we can see that in this way it was possible to detect in the whole time series some anomalous events. In particular, the majority of them are around this peak. I also I've tried to do that for the resample time series only with the maximum values, and here are the results. And so my conclusion is that using the 10 series as it is can allow you to detect the events, and it's good. It can be used in this way. And I prefer to use the rolling mean to find anomalies than to use IQR or the isolation forest, as I've done before, because in the first two cases, you had to define a percentage of anomalous values or a threshold on the IQR. And in this case, you have to define only the factor of difference. And this is more, in my opinion, probably this is more significant for the purpose of the experiment, so to find earthquakes and peaks and so on. But this is only the beginning. I suggest to probably use LSTM instead of these techniques, because when you have a large amount of data, like you had in this case, it's a good idea to use them. And probably a deep learning algorithm is better.
Thank you very much. There is a question on the chat. It says, did you filter or pre-resample? So it's from Marcelo. I don't know if you can open your mic and ask a question.
No. Okay, I just looking to what she presented. Like when you said you resample, you consider the frequency content of the time series, or you know, like you apply a filter to this or not? No,
I do not filter.
Okay, so you just make a new sampling on it.
Yes.
Okay. Yeah, no, that's something. And then because like this is something to me, like when you look to the data, did you try to think about frequencies and separating a little bit? Like yeah, I don't know from which fields you came from, you know, but especially for the first time series that you show in the beginning, not this, that is pretty clear, the events, but on the beginning, yeah, like those, it's completely different behavior.
Yeah, this one.
Yeah, like these ones. Like how was your feeling by looking at these, and did you thought about frequencies or?
No, I this one I've seen it today because the first attempt were with the first one, and so I've already done the most, so I only tried to detrend it, honestly.
Yeah, because okay, it's interesting. Like by your talk, I learned a lot of new ideas that from other fields, like many of the things. I think this rolling mean is very similar to what we do in seismology with the STA, LTA, but it's a division of two rolling means. Okay. If you make one rolling mean of short and one rolling mean of large windows, and you divide one by the other, you enhance all the signals you want here. Because one keeps tracks of the statistics of the noise, that it would be a different frequency content of the events that is a transient signal. But it's nice to see. It's just the comments, but it's nice to see a person from different area to look to our data, you know, and make the discoveries. Congratulations.
Thank you.
Thank you very much, Chiara.
Also, I want to say something that is important. If in your project you are like planning to use this data, and maybe someone from your field is able to detect earthquakes and he wants to label them, I think that making this data openly available with the label can be significant, because so others can try to find the earthquakes, and you have labeled anomalies. It's interesting.
Yeah, we have label. Like, it's
okay.
available in the internet if you search.
Okay.
It's but we used to call label as parametric data. Like events parametric data, it's where we store our labeling to what we discover on the Earth, on the time series. And there is another semantics behind it. And like for this T0 that you saw, it's a legacy format. You will not find in OBSPy the definition. You know this T0 that you talk in the beginning?
Yes, yes. I don't know what I haven't understood exactly what it was. So yes,
it's the number of seconds from the first sample of the seismogram until the phase. It's a label, but it's a very old format from the 70s. That is the SAC, that is Seismic Analysis Code. And it was a metadata in the header that points to a mark in the time series in relation to the beginning of it.
Yeah, I tried to, this is the operation that I've done. I have sum up these seconds with the start time of
exactly.
sequence. But this value wasn't present in the labels of the UCT time available in the file. So I've tried to subtract some values and add some values so I can find an interval. But this is, I know this is not the right solution, obviously.
Yeah, yeah, T0 summed to the start time is a mark in the seismogram, basically. It's just a point. But I will send you a link.
It was a good reflex to I mean, to get out of the problem in the way you chose.
Exactly.
Yeah.
Indeed, what I find interesting is that once she was able to read the files, then during the discussions we had, she decided to see the problem as a time series problem with outliers detections. So she already had experience with that, and then we see the results, which was okay given the time that she had. And we know that, for instance, she has, with 2 more days, maybe we will have something more interesting. The only missing part is the interpretation of the data, but because there was not enough time, but I just want to say, Kiera, it was really a good work. You were not pretty sure about the results, but yeah, you did an amazing job. Congrats.
Thank you. It was yes, I know there's a missing part. It's true also because at the beginning I wasn't able to see the data, so I've decided to miss this part and try something. But I know this is not the right way to do it. This is normally it's not the way you do research about data.
No, but it is good. In fact, this is the way. I mean, they gave you a bunch of data, and then you manage to read the thing and do something. Then, if we collaborate more with all the people, the experts of the field, of course, you can understand and apply better algorithms. Then the fact of the idea behind using Colab, for instance, was just to simplify the interaction with other members of the challenge. Well, in your case, so within the other team, you were almost alone. Jaime participated a little bit in the discussion, but I mean, you did the job. But you also put in evidence the fact that using Colab, there are some limitations. So it makes sense to use other type of infrastructure for running the algorithms. For instance, you proposed LSTM. And you already know that this takes some time. So now we know that for sharing results, Colab is good, but for running some other interesting algorithms, you need some more resources, maybe a cluster, right?
Yes.
So, and this also will help the community to discuss about what it is needed to work on the topic with this data.
Okay. Thank you very much. It was also interesting for me because I learned to use Colab. So I'm happy for that.
Cool.
Are there other questions in the floor or in the audience?
I would like just to
Augusto, yes, please.
So first, I would like to congratulate you because considering the very short time you have to develop the challenge or to deal with the problem that's amazing. The results you get, but I wanted to give you just a comment, following more or less what Professor Marcelo Bianchi said. If you consider just the peaks of the T0s that you had in your data, you could jump more of the process you had, So if you could cut the data, you could see the earthquake in your data more clearly. You didn't actually needed to do all that processes, but what I'm talking about it's a more towards point, So because of that, I'm telling you that you did actually a great job. So, but just a comment, if you wanted to go ahead, I would give you this hint to cut the data around the peaks and using the notebook I provided, using a more hints using NobSpy, not only cutting the data, but doing the trend removing that you applying to data, And I think you can more directly go into the challenge main point. But again, I see that you have developed a great job. So congratulations. And if you had any doubt and if you wanted to go ahead, please do not hesitate to contact us. Okay.
Okay, thank you very much.
Thank you. It's also a message for us that we need to exercise ourselves in defining the challenges. And if there are some elements that we can provide that can help people not start from zero, particularly because not being from the domain is very challenging when you get acquainted with the data. I mean, there are libraries, there are other people doing things, and you are facing alone with no background support in order to address something very new. So that's also a message for us, particularly for us, in order to really make the exercise of doing this explanation and preparation of the statement of the problem. I think that, I don't know if someone wants to ask.
Yes, I just want to say, well, Jaime didn't say anything, but at some point he mentioned that for him it will take some time in order, because he understood the problem, he knew what was the objective, but I have the impression that the technological aspect was the thing that was constraining him to some extent. So I suppose that it will be interesting to hear the experience of the students in order to also determine whether, well, we need to state the challenges better, but also to identify what are the skills that they need in order to tackle the problem.
Yes, lets me go to the last part of the event so that we can close. It is that we will send an evaluation form to participants, and we are really asking you to provide comments, particularly those that have addressed the challenges, because this was also our first experience in proposing the challenges. So any comment of your impression or the specification, etc., will be very helpful for us to state better the problems and move into an enhancement direction. Thank you very much. We are just coming to the end of the session. Of course, we will provide awards, but the awards we have to interact between among each other to decide about the awards. So you will be notified directly about the results of the challenges, and you will receive a virtual award from the organization after the event. But we really appreciate very much your work and your adventurous decision of addressing the challenges. We really hope that it was also a good exercise to face these kind of problems and have a look at them. Thank you very much. And with this, I would like to thank the whole audience that has been following us during a week. It was very intense. I think that we all learned a lot from each other. So I really thank you for your participation, for your contribution, for the preparation of the event. There are many interesting challenges that we still have to address, but we still have a year of coordination action, and of course a year in which we will contact in different ways the participants in order to propose new ways of cooperating and going further in this adventure of geophysics based on data. So with this, I'm going to close the session. Thank you very much.
Genoveva, some people are actually, one person here is asking for a selfie.
Yes, so if those that are visible, I know that some of you are working at home and you might be not visible, but those that are visible, please open your camera so that we can take a photo. Okay. For the
I changed my computer, so I don't know how to take photos on this computer here. So someone else can do it.
I will
capture the screen or something like this.
Yes, I will capture the screen. Hi, it's good to see you. So in 1, 2, and 3. So you, if you do not object, I will share this also in social media so that you can see your faces at the end of the event. We didn't take one at the beginning of the event, so we will not know whether you whether you change faces. But anyway, thank you very much for all this.
Thank you, everybody.
Bye-bye, and happy holidays. They're coming, they're approaching fast. Happy holidays with your families.
Thank you, everyone.
Looking forward to that.
Yes,
Take care, guys.
Yes, and for the next year. Bye-bye, bye-bye.
Bye-bye.
Thank you very much.
Thank you.
Thank you.